Hi. Yo. Welcome back to the stream where I'm making my own programming language. Hello, Veldek. Yo, how are you doing, Veldek? As you were streaming the racing. How was the racing? Did you beat everyone? Is it like Noita but with cars? Imagine a game which is like Noita but with cars, where every pixel is simulated. You have the same crappy physics like in Noita. That would be wonderful. And then the cars are magic, of course. And you drive through all the fluids and stuff. It's an old mobile game, free to play, nothing much special. Just impressed how aggressive it is when it comes to in-app purchases. Oh, you were just like looking at the marketing. Not the marketing. Looking at the looking at what? I just played it years ago. Yeah. All right. What am I going to do today? How are you doing anyway, Weldek? When is the next burger festival? It's July already. Surely there is another one around the corner, right? In 4 months or so. Let's see. Wait, I thought it said every month, but it's every like half a year. Okay. Hmm. VS Code is weird. It's supposed to highlight the things that are ignored with the gray color, like over here. The Duranv is gray because it's ignored, but build is also ignored, but it's not grayed out. And the cast.pam file is also ignored, but it's also not grayed out. Is that an issue with VS Code? Din, 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 din. You might be streaming in future learning of Microsoft API for AI. I see. Wait, what's the Microsoft API for AI? Microsoft API for AI. Azure AI services, that's the one? Speech to text, text to speech, vision, video indexer. Bam, 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 bam. Detect and identify people and emotions in images. All right, I need to come up with a plan of what to do today. I need to come up with a plan. But maybe the plan is very simple. I'm just going to continue working on the guessing number game over here, right? I need the guessing number game to continue. So for example, last time the thing that I did, it was this unwindable block, right? But it is a little bit weird that we have the unwindable block like this, and then we say unwind the block, right? Wouldn't it instead be much better if we actually said just loop over here, and over here we just said break, right? But I feel like now we can do that with the features that we already have in the language. We can compose them to have the loops that we can break out of. Wait, can I? Maybe I actually cannot do that yet. So the thing that I want to figure out what block do I need to unwind to, right? Yeah. That's the thing. So we need to basically unwind where? To the current loop. To the current loop. Context. Token. That's what I want to rewrite this into, I think, if I say break. So we need the context system. Yeah, let's do the context system real quick. We're going to make it be, maybe for now, just runtime checked, not compile time checked. Right, hello Nigel. So the context system, over here, I say the main is the function that takes IO, right? But this is right now just completely ignored. Right, so but what this should allow you to do is you should be able to say like current IO. So IO is an object that allows you to do the input and output, basically, right? So RNG, for example, would out of the IO get the random number generator because that's part of the IO, right? And all of the other parts, like printing, should also have the STD. Yeah, like printing is taking the output out of the IO. Input takes the input out of the IO. So that's what we need. Also, my syntax is still like hard code, like it's not hard coded, but it's like not part of the standard library right now. So I could also work on that, but I feel like it's not super important for now. So whatever. So yeah, I'm going to have another thing, which is going to be figuring out the current, so like injecting a context and getting the value of the current context. Right, syntax for current context, current context. It's fine, we don't need protection. So it's going to be current. Current. It's just going to be current. Oh, wait. Yes. We were also thinking of a different name for this previously, because current is a very useful word to use in programming. So we shouldn't make this a keyword. What's the advantage of that unwindable loop block? What do you mean? Like, what's the advantage of being able to break out of the loop? Or what? What's the advantage of having this split into two things, unwindable and loop? Or what's the question? Breaking out of the loop is basically not a special feature, but it's a composable feature out of the loop and unwindable blocks. So like it makes the language technically simpler, right? Because there is less thing to learn, kind of. You want to break out of the loop, why can't you? Because, I mean, that's what I'm going to do, but breaking out of the loop is a feature that's composed out of separate, out of two features, basically. Right? It's not a built into the language, because like why would it need to be? Like how is the breaking out of the loop different from, for example, returning out of the function? How is breaking out of the loop different from, for example, raising an exception? There's no difference. So we make all of these features be the same feature. But then again, we have custom syntax, so you will be able to just say break. But it's going to be under the hood implemented using this thing. That's the idea. And then same as that, like returning from a function also is going to be not a special feature. It's implemented using the same technology, basically. So like I don't need to implement breaking out of the loops and returning out of the functions and throwing exceptions. I just implement one feature. And also, like if we talk about returning from a functions, for example, sometimes you want to return from not the current function, but the outer function. I don't know if you ever wanted that, but especially when you write something like in functional style, like for example, you have a list and you say list.map, and over here you have a closure, right? Which has like element, and you do something with element, right? But sometimes you cannot do something with the element, so you say like, I don't know, if some condition, then you actually want to return, right? But you don't want to return from this closure, you want to return from the function in which you currently are, you know? So this return should be returning not to this thing, but to the outer function, right? Have you ever needed that? There are some languages that allow you to return from outer functions directly, like Kotlin has such a feature, for example. But I don't want to special case it, and we're just going to say that unwindable. So like every block has a name, and we can unwind to that block. Need that often in Rust, yes. Might have needed it, but probably avoided it using some workaround. Yeah, like in some languages, like in Rust, you cannot even do that. So instead, like, and it becomes like really annoying a lot of the time. It becomes really annoying sometimes. Now, if I can show you an example. Yeah. Like obviously there are ways to like write code without it. It's just like more verbose, harder to read, and like there are unnecessary details because of the workarounds. You know, they're ugly. So on one hand, because you don't have a feature to return to the outer function, it does. Like how do I say it? Like it's a powerful feature, right? It's a powerful feature, but it's also a feature that you kind of like, I guess, need to learn. So not having it and using workarounds instead is more like, because people are used to not be able to do that, right? So people don't need to learn this as a new thing that they can do. So it might seem like the language is more difficult because of this new construct, kind of, right? But in my opinion, it actually makes programming easier, even though there's one more thing to learn. I mean, at the same time, I'm trying to make like again, like I am introducing this new thing which is not really there, right? But at the same time, I'm removing the other features and implementing them using this new feature, like breaking, right? Because people are used to be able to break out of the loops, right? So, like, I don't really want to get rid of their ability to break out of the loops. But I also don't really want it to be a core feature. I feel like what we should have actually, like in the language server, when I'm hovering over here, like, you know, like for example over here, right? This over here, this triangle. What is the triangle? Some people might not know, might not understand immediately what this means, right? Even though I think it's relatively obvious. Like people have used Bash, right? Although in Bash it's just not a triangle, just a vertical bar, but still. I feel like we should be able to basically understand immediately what a syntax means by hovering on it. How about that? Because this over here is a custom syntax. It's implemented, like this is not a built-in language feature, right? So what if I could hover on this triangle and it will tell me, or I can like go to the definition and it will bring me like, you know, over here, right? So if we have a triangle like this, then the code is just being rewritten into this code, right? And you look at this and it just says call a function, with argument being the first thing and the function being the second thing, right? Although yeah, I think like showing this on hover basically would make sense. Pipe argument to function, yeah. Pipe argument to function. But like this is the simple example, right? Like you can understand this. But maybe some of the other ones are going to be, I don't know, more difficult. Or I mean, even if you like, once again, if you have like the something that is really commonly used, like a break, right? I could just hover on a break, and you will see that the break is actually implemented using the thing. Do you have possibility to partially apply arguments? No, I think I would prefer not doing that. No, like I mean we'll see. Like I personally feel like it's weird. It's a weird feature. It's useful, but most of the time you don't partially apply arguments. And Cas do automatic function differentiation? Not yet. Hello, very much. Construct a lambda explicitly instead. Yeah, like, why don't we just construct a lambda explicitly if you want to partially apply a function, right? I understand the idea of currying, but I feel like it. I don't like it too much. I don't like currying too much. Like we use it kind of in OCaml, but I don't like it. But yeah, automatic function differentiation. I think we will be able to do that. Yes. But right now it's not there. Oh, by the way, guys, I made the progress on the playground. Look at this. Look at this, guys. Look at the playground. Let me just copy the guess a number game here. The guess a number game here. Also, yeah, I made the playground save your code in the local storage so that if you reload the page, it's going to stay here. And you can run it. And it's going to have the input here. So we can actually play the guessing number game in the browser now. 5 greater, 4, 6, 7, 6, I guessed. GPT can do CSS. Yeah, I mean, I asked ChatGPT to do the CSS for me. I don't know. Game dev in the browser, yeah. Yeah, and if you missed it, also we have the like I mean, all of these things are working, and like there was a time where the playground was really like not responsive, but now it's really quick to show you the errors. Like it's almost instant. Look at this. showing you the errors. It was taking like a second before. But yeah, obviously right now the standard library and like everything is really small, so like, yeah. We are basically ready for D2 gem. Maybe? Actually, wait, hold on. Are we ready for the D2 gem? So this over here, I am not transpiling cast to JavaScript, right? We have transpiled OCaml to JavaScript. And OCaml is, so we have an interpreter in JavaScript, which can interpret and compile this code, right? Can I do this to actually like make a game? How would I interact with like other JavaScript features? Because because this is like hard coded, like the way I'm doing this guessing, right? This is written not in cast and not in OCaml. This is written in JavaScript, kind of like I just have a hook to set the way to input the things. Inline JavaScript. I mean, but input is like hard coded. I don't want to. I would rather like try to not hard code the things somehow. Oh wait, but I can. I feel like I can do it relatively easily, maybe. Like I think in OCaml we have the way to just do JavaScript, right? So cast JavaScript. Let's take a look at this here. Like there is like I can just literally generate raw JavaScript code in OCaml, right? Unsave JavaScript exception. There you go. This is the thing. So I can just generate JavaScript exceptions, JavaScript expressions, and so I can have like a native. So I can basically say, in my cast code, I could have like a way to do what? I guess like interpreter should be able to have a native function, which is like an inline JavaScript exception, right? So like this should just be a native function, so that I can call this from cast, and then we will be able to do everything. That's right? Maybe. And then one of the values should be basically the JavaScript value, right? But then it should be only possible if I'm compiling to JavaScript. Which brings me to another question. How do we do this? So like, can I make this a module, an optional feature? So if you remember the minicast that I was trying to have as an idea of splitting all of the features of the language into separate modules, right? So we have a module which just implements a string, for example, right? Because we can have strings in the language. We can have a module that implements numbers, and then we like combine those modules together at the very end in our like main binary. We compose the language out of the separate features somehow, right? Because instead of the way I'm doing it right now, which is basically having a single like type here, which specifies everything that can happen, right? So like, how do I make this over here extensible is the idea, is the question, right? And so if you saw this thing that I was sharing in my Discord, where like this thing, extensible data types. I don't know if have you seen this on accident, maybe, Raymarch? It's called context generic programming. This thing has been like the guy has been showing this for a while now. Have you seen that? Context generic programming in Rust? You have not? Maybe you should take a look. I think this is interesting. But this specific blog post is about specifically the same problem as I was trying to solve. Where, so you have this problem, right? we want to have like an expression like this, right? We have a literal or a plus or a multiplication, right? And we can just evaluate it like this using a global match, right? But this makes it not extensible. It also makes it so that every expression here must live in the same crate. The evaluation, everything must live in the same crate. That's why my Rust codebase was also slow to compile, because everything was in the same crate. But how do I split it? It's like, that's the difficult problem, right? Hire him, hire me. Yeah. So basically, over here they have a proposal to have extensible things in Rust like that. So instead of having a single enum which specifies all of the different kinds of expressions, you have each crate you can have each crate specify only its own parts, and then you will compose it later, right? So for example, if we have an expression which is like literal, plus, and multiplication, then you can have one crate specifying just the plus, right? And then you specify how to compute specifically just the addition, right? It's like a runtime equivalent of trait implementations. Yes, but this is over here. It's not even runtime as far as I understand. This thing is actually zero cost. So it's done using the traits. So over here, it's so it's basically you're being generic over the final thing. That's literally exactly the same as I was trying to do myself in the minicast when I was showing it to you. So you have the final thing that combines everything together, but you don't know it yet. So you make it your dependency by having it as your generic argument, right? So you have the context, evaluation context, and then you have and then you have the generic math expression. So you don't exactly know what the expression is, right? So the expression plus, it takes as an argument the inner expression, right? Because addition can have inner expressions. We don't care about, but we don't know what are all the variants of the expression yet. So this is a generic argument here, right? So then we specify the way to compute an addition, but in order to compute the addition, we need to know how to compute arbitrary math expression, right? And then we need to also be able to add the result of every math expression. So this over here is also generic over the type of the math expression. It's not necessarily about integers, right? You just need to be able to add the results. And as I understand, this is actually all zero cost in Rust. So in the end, they have some macros here. So in the end, you basically just have your same enum, and then you want to delegate the evaluation to the concrete implementation here, right? I mean, this is kind of seen in Rust sometimes. To implement everything twice, once in the type system and once in the braces below. What do you mean braces below? What is braces below though? Hello, THRSHN28. Wait, how do you pronounce that? The imperative part. Wait, what? What's the imperative part? You'll have to look at this later. I suggest, yeah, I think this over here, this one is solving the real problem, the problem that I have when working on my language, right? So yeah, look at that. And I think in general, this context generic programming, you can look at other things. So you it allows you to in general have things it allows you to overcome the orphan rules and stuff you know, in a way. It's interesting, but I do expect that this, if you actually use this in Rust, it will cost you a lot of the compilation times, because this is going to be really heavy on generics, because you're going to be generic over the final result. Like you don't just have the single enum anymore, right? Which is not generic. Shane 3.0 rewrite incoming. Yeah, but you specialize once. Yes, but you specialize once, right? In the end, like basically in your final like binary or somewhere, you combine all the things together, which is where you specify the specialization like rules, right? How to like actually, how the things are actually implemented. Yeah. So I actually went ahead. Let me show you. I basically didn't sleep last night, and I implemented this thing, but in OCaml. Like I was trying to do this in Rust before. Now I have the same example in OCaml. So here's the simple example, right? So here's the mini cast. I have an expression which has additions, constants, right? And we want to be able to evaluate this, right? So we have separate features like addition, right? So how do I specify addition? Addition is an expression which has a left-hand side, which is an expression. But what is this expression? This over here is depending on the final like combined cast, basically, right? So addition depends on the final value. So we do it like this here, you know. And in order to evaluate the addition, I need to be able to evaluate the left-hand side, and to be able to evaluate the right-hand side somehow. All right, like this is we don't know the concrete implementation here. We're working like abstractly here. Yes. And in terms of the dependency, I need to make sure that my value like satisfies this trait, and about the expressions I don't really need to know anything. And then in the end I like combine the things together. So this allows me to move the parts. It allows me to split my code into modules, which are about certain features, right? Instead of right now the way it works is that I have the dependency graph like this, where I have basically the so I have yeah, I have basically just interpreter and compiler, right? And these are the two big crates. These are the two big modules, because compiler knows about every single thing that we can compile, and interpreter knows about every single thing that we can evaluate. So instead of having, the idea is basically, instead of having interpreter and compiler, which depends on the interpreter, and these are like super huge modules eventually, once we have a lot of features, right? Instead, we split all the features, not like this, but by semantics, right? So for example, we have math, right? And then we have I don't know, unwinding, which I implemented yesterday. And then we have I don't know, delimited continuations, right? So we have all of these separate features. Every single one of them knows how both to compile the math expressions and how to evaluate them. It knows how to compile and how to evaluate the unwinding, and how to compile and evaluate like these things. And then in the end, we combine all of those together into compiler plus interpreter, like this. Is this just inside out generic so that the orphan rule doesn't kick in? I don't know how to describe it, but yeah, that's the general idea. Because like even although I have split my code base into a lot of modules right now, the compiler and interpreter are the biggest one, and they are going to keep growing, and they are going to grow like infinitely, basically. And that's the problem. That was the problem with my Rust code, and yeah. and it's a problem here. But right now we have a small language, so maybe I should like try to refactor it immediately into this new like structure. But it also like it's weird. It's a little weird. It's a little weird because not a lot of people are doing that, right? Being generic over the final thing. At the same time, I know that OCaml has another feature though. OCaml has one more feature, which I was actually going to try. It's called Variadic. No, not Variadic. Polymorphic variance in OCaml, right? Let me try this real quick. I want to know how this works. So yeah, and by the way, it is a lot more code because everything that is over here is implemented is basically implementation of this thing. We have a single type, which is one of the three variants, an expression, which is one of the three variants, and we just have the evaluation, which specifies this, right? But this is just three. This is very simple language, so this is very small, right? But this really grows when we grow the amount of values, the amount of expressions, and like we also like this also doesn't have the type system and stuff, right? Yeah. So yeah, let me try actually to play around with the things. So polymorphic variance is like anonymous enums, as I understand it. And then you have like this and that. So you specify the type in square brackets, and then after the first square bracket, the opening one, you have either the more than or less than, or no symbols, maybe. And this means that basically, like, you are specifying the type that has at least this variant, or at least these variants that are specified, or at most, I think. Like, where is it documented? What's the symbol? Yeah, so the more than and less than inside the variant type show that they may still be refined, right? So basically it means that I'm specifying not the final type, but only like some subtype, right? Either by defining more tags or allowing less, yes. So I'm actually interested in this. Let's say that basically I want to have, like, let's say that I want to implement part of the language which is just about addition, right? So so we want to have module add, right? So module add should be what? Like, I feel like it's still basically like I need to be able to make it using the dependency, which is like cast, which is like the final thing. Where, so yeah, so like, so what do we expect out of the final thing, you know? What do we expect the cast to have in the end? I know that the type of expression should basically be at least addition, right? Because this module is implementing just the addition. So we specify that expression is at least add of expression and expression, right? Isn't this like simpler? And then we specify also the more than, which means that it must be at least this, but it also can have other things. No, the type variable is unbound in this declaration. The type as a variable a is unbound. I don't see any variables a here. Hold on. Maybe I need to. So would you then in Rust have still have to write down the huge enum at the very top? Yes. And I mean in this language too. In this language too, like somewhere down the line, I will just have the thing. But the implementations are going. The idea is to still split the implementations, right? Yeah. Into different crates. So like, you need to know what to do with all the other variants without really knowing the other variants, is the idea. right? So we know that that my cast should have at least this variant in the expression enum, right? And we also should be able to evaluate the expression into a value, right? Where value also is the enum, which has at least the variants, which are int and I don't know, int and float. You know, because addition will only work for integers and floats, right? And for all of the other variants, it's not going to work. You know, so down the line we will need to specify at least these variants, but we will also be able to specify others. Unbound type constructor expression. I need to Dune build watch, right? It says success. But okay, hold on. Is the OCaml language server is not allowing this, even though the language itself allows that? Is that really what's happening here? I think that's what's happening. So let's say that, like, down the line, I will say module cast. Is the thing where value is int, float, and string. Right, so now we have all of the three variants. Expression is add or print, for example. And we have eval expression to value is match expression with. So basically and then so like in the final thing, we're actually going to basically delegate the implementation of the add to this module, which is specified somewhere else. So if we have the add A and B, then I will say add eval and B. I have a print, then I will like this one I will just hard code, whatever. I don't know, fail with to do. Right, and then what is add? And add is the concrete implementation of the add here, which depends on this thing, which is why this must be recursive. This must be recursive, and I also need to specify the fact that add is this add. So this is like, you know, yeah, so I call this like all of the parts that we will combine together is going to be here. So I say parts add make using cast. But the recursive ones, they require the signature, so I need to have the signature here. Where signature is it's like that. Eval expression value, right? And add is parts. I don't know. Add is eval So add basically can evaluate only only like some parts of our expression. So like basically only the add expression into value like that, right? The type constructor cast expression expects a 0 argument. It says success. Wait, there is no way it says success. I think this is not being used. I say module place play. There you go. Oh, so this actually is the error that exists. A type variable is unbound in this type declaration. What is this? In type this as a. The variable a is unbound. So I cannot do that. I cannot have the abstract type like that, right? Can I make this generic as a? Does that work? A expression. Is this correct syntax? It's a little weird. So this one is generic basically over the final thing. Is that what is happening here? Interesting. As I feel like this is not really explained well here. Because, yeah, I guess it says that the type of in the module must be a concrete type, but this is like a generic type, right? And then this syntax is not even explained in this on this page of the polymorphic variants. So evaluate should work. Says as a. I don't understand this. Yeah, I think I cannot specify abstract type, right? Hello, Regicide. How are you doing? Camel, can I have a module signature that says that a type must have at least given variants, but may have others. No. A camel doesn't support open or extensible variant types in module signatures in the way you're imagining. You cannot specify at least these constructors, maybe more, in a module type. What a camel can do, so we can have polymorphic variants. Type T is more than A or B, must have at least A or B. That's literally what I did. But this only works with polymorphic variants. Yeah, so like more than, less than, or equals, not normal ones. Polymorphic variant plus open recursion. Combine that with functors or first-class modules in unit dispatch. Define an extensible GADT or pass. Oh, wait, hold on. There's also an extensible types in general, I guess, in OCaml. Right. But the problem, though, if... let me take a look at that. Extensible. OCaml extensible variant. Extensible variant types are variant types which can be expanded with new variant constructors. Extensible variables are defined using the dot dot. Oh, just dot dot? Okay. New variant constructors are added using plus equals. Pattern matching on an extensible variant requires a default case to handle the unknown variant constructors. Maybe, like, I mean, maybe like this is not exactly what I want, right? Because this is basically going to be checked at runtime if I forgot a variant to be handled, but it might be like just more practical, maybe. So, you know, I would specify the cast, like the abstract cast somewhere, right? Which says that we have type value, which is dot dot, so it's extensible. Let's just do it from scratch. So have a value extensible, we have expression extensible, we have yeah, and then we will have a evaluate. Oh, so this is actually very very similar, I guess, to the exceptions, right? So in the exception API, what they have, so if I want to evaluate, which is expression into value, right? Since I don't really know any variants, right? How do I even evaluate this? Because this is supposed to be extended in other places. So how do I do this? It means that I need to store the actual calculators, right? So we will have the evaluate implementations, which is a reference to expression into value option list reference. And then we will have a function which is called, like, call a register evaluator. So register evaluator has a function which is like the evaluator, which is expression to value option, like that. And this is function f into evaluate impulse is f followed by evaluate impulse, right? So I just add it like this. This is a reference to empty list originally. And then when I evaluate, I basically go over all of the implementations, right? So this is just going to be done at runtime, though. That's the downside of it. So we just we go over all of the implementations like this, and then we iterate over them. Or I guess we don't iterate. We say find map. Find map function f expression. So this is function expression into this, right? This will return an optional value, and then we'll say option get, right? So and this is going to basically panic at runtime if there is no implementation for this specific expression to be evaluated. So if no one knows how to evaluate it, then we're going to panic at runtime. This might be the more practical way of doing it, actually. You know, Camel, even although this is going to be checked at runtime, I would, because I think the other, like this stuff, even although it's like zero cost in Rust, I feel like, you know, Camel, it's a little weird. I mean, I have the proof of concept. It's kind of working, but I'm not really confident in that. And this is really like short. And then basically I would have a module add somewhere, right? Which is implementing the addition, right? Which is implementing the addition. And I will have somewhere module, like, I don't know, integer, right? The module integer says that type cast dot value plus equal int of int, right? So we specify a new type of value here. We register the new type of a value, and addition, this one defines a new type of expression, which is add of two expressions like this, right? This is actually looking very simple, at least. The downside is that it's runtime checked. But I think it's fine. And then I will just basically register evaluator. So, which is going to be saying that if I have add A and B, then we are going to evaluate A like this. We are going to say that B is evaluate B. And then I'm going to match A and B with... So this should be... I guess this could be called... Can I just call this like T? Probably like not. It's just like, you know, I will fully qualify this by saying int.int is the weird part of it. So I have int A and int B. Then we can calculate it into int A plus B, right? And then if it is anything else, then we return none. So basically returning none here says there must be another implementation somewhere else which knows how to evaluate that expression. But we probably need to like say that if the left side is int, the right side is anything, or left side is anything and right side is int, then we also know that this should like just fail, right? Int only addable to another int, right? So we specify that they must be the same type, basically, this way. Wait, what? This pattern match is not exhaustive? Oh, this pattern match is not exhaustive. Add, right? Yeah. And then if we have the any other expression, then we just return none, because we only know how to evaluate additions, but not any other expression. This actually is very short, so maybe this is the case. But this one should be before that one. Yeah. It moves the checks to runtime, though. Do I like this? Do I like that? So yeah, and over here, basically this module depends on integers, but we could have like other modules specifying other types, so which this would not depend on, right? But addition depends on like just the core and knowing what an integer is in this case. Interesting. Okay. I was starting to do something else, right? I was starting to do the current contexts. Maybe we undo that. So do I try to do this instead? Let's see. Let's see what they say in the documentation. So pattern matching requires the default case. The pre-existing example is the exception, right? So like you specify this new exception, right? Extensible variant constructor can be rebound to a different name. This allows exporting variants from another module. Type expression attribute plus equals string, which is expression string. Oh, I see. Now works stir. Okay. So it means that over here, instead of saying add.int.int, like I can obviously just open int, but if I want to import it, I will just say that cast a value plus equal int which is equal to int.int, right? And then instead of saying int.int here, I can just say int, I guess. Extensible variant constructed can be declared private. As with regular variants, this prevents them from being constructed directly by constructor application while still allowing them to be destructured in pattern matching. Wait, what? Oh, I see. It's in the signature. You can define it as private so that it's not a constructor, it's only a destructor. Alright. Only pattern matcher. Private extensible variant types. Extensible variant types can be declared private. This prevents new constructors from being declared directly, but allows extension constructors to be referred to in interfaces. So we have a type D is private extensible thing. It allows extension constructor to be referred to interfaces. I'm beginning to think that the winning languages in the future are the ones that know how to provide cool features that still play nicely with dependencies and compilation times. Yeah. So like, I don't know if you just came back. So I found another way of doing the same thing, which is the extensible variants, right? This is, if you like, I don't know. I've shown this before, right? But basically you have an enum which can be extended in other places. So like you literally define your enum all over the place. Originally you just say that there is like no variants, and then in this module I specify this variant, and in this module I specify this variant, you know, and then in the end, like trait implementations, it's not exactly like trait implementation, it's literally like an enum. I don't think there is there is no alternative of that in Rust. I mean, like the alternative in Rust is like the din any kind of, but it's a little more typed than any. I guess. So yeah, like the problem that I don't like here is that it's now checked, moves the checks of exhaustiveness to runtime. That's the only problem. But it is really short. Din trait. I mean, yeah, I guess it is the din trait. Yes, it is the din trait. But then, so in Rust, you would say that so expression is a trait, and then you specify your own struct here, right? And then instead of pattern matching, you would just do instance of, or I mean, you will like try to dynamically cast to all of the variants which you know about back to Java. Yeah, basically. Basically. So yeah, it's a little bit more better than that. Okay, so that's all. That's very short. As a newcomer to this, why did you choose Rust? I'm writing OCaml. Hello. But Rust, I'm writing Rust for the game, and I mean, yeah, I mean, I'm mostly am a Rust programmer. But yeah, I choose Rust because it's a good language with which checks for my bugs at compile time, which I like. I don't like being responsible for my bugs. If the compiler can check for me, then it should. That's how I choose Rust. I want to not be able to write bugs. But then I had a problem with compilation times in Rust, which is why I have been rewriting my project, my programming language, into OCaml. And I am right now basically talking about a way to split my project into modules or into crates in Rust. Because in Rust, I just had a single huge crate, which was like knowing about all of the types of values and expressions in the language. And in OCaml, we have multiple choices of how to do that. In Rust, we also could do something like this. Extensible data types with context generic programming. I'm just thinking, what should I do? Because in this rewrite that I'm working on right now is still relatively small, so if I do it right now, it will be less pain in the future. Coded 5, hello. Let's ask ChatGPT, should I use extensible variant types or not? No, unless you have to. Extensible variant types in OCaml are a trap with sugar on top. Why you should avoid them? Poor pattern matching. You cannot exhaustively check an extensible variant. Yes. OCaml will never warn you about the missing cases because it cannot know how many there are. So enjoy your silent runtime bugs. Extensible variants are global. You cannot declare type T is this locally in a module and add it to elsewhere cleanly. No ergonomics. You cannot list them. You cannot introspect them. You cannot reason about them like normal variants. When they're barely acceptable, plugin systems. But it's basically is a plugin system, right? So I want to have a plug, like I want to split the language into separate like plugins which implement certain features. Use polymorphic variants for extensibility with type safety and better ergonomics. Use extensible variant only when you need runtime extension. So why does OCaml use them for exceptions then? Huh? Because exceptions are wild, global, unsafe, runtime only. Because raids can happen anywhere, you're not supposed to match every exception. It's inherently non-total behavior. And that's fine for exceptions. Would using them to implement a programming language for types of values, types of expressions make sense? No. I'll use extension variables so I can add new expressions types modularly. Reality. You lose exhaustive pattern matching. The single best thing OCaml gives you. And you end up with brittle spaghetti. Let's say you do this. Type expression is this. Integer or add. Now you try to write an interpreter. This. OCaml says looks good even though you forgot something. No warning. Ever. That's stealth bugs. But I want extensibility. Then use polymorphic variants or functorized modules. So that's like the other solution that I was looking about. Polymorphic variants, best if you want open extensibility and pattern matching. So expression is this. And then eval is that. Want to extend? Expression extend is expression or even more. Now your interpreter knows what's missing. It can warn you if you forget null. Alternatively, use normal ADTs and refactor when needed. A real EST doesn't need extensibility unless you're building a plugin system. Are you building a plugin system? If you are, you're already halfway to designing an in-house hellhole that deserves a type, class, or trait system. One more time for the people who wrote your languages. AST and Rust, you'd be forced to do it right. But then, let's say I want to have but this is not extending. It's defining a new type. Yes. Polymorphic variants are structurally typed, not nominal. Okay, let me no. Oh, look at this. Latrec eval. More than. That's literally what I was trying to do earlier. So this function works on any variant that has at least these. Hold on, let me copy that. Module extensible. Module polymorphic. Okay, let's see this. Wait, what is that? Syntax error, unclosed struct, expecting. What? It must be in parentheses here. And now this is like non-exhaustive. Here is an example of a case that is not meshed, some private tag. Right, so we have the function eval that is working with yeah, so this is like generic over the final actual type of an expression. Okay. So once again, we need to say that if I have module add, which specifies just the addition, right? So this should be a expression. And then I should say type A expression is that. And if we say that if it is no, this one should be like equal. Equal is just that, right? Universal type variable cannot be generalized. It is bound to this. Wait, what is that even? Recursive type pit of despair, where A refers to itself without a base case. So you're trying to do something like this. It gave me a type that includes itself. It's not fully known, and I'd explode into infinite recursion. This is an explicit type definition. I'm going to scream. Define a named type. But this type should be specified in some other place. I don't get it. Like, I only want... Like, technically, I'm just saying that... Oh, wait, if I say more then it's fine. Right? But then it's not exhaustive. Oh, and this is, and if I do this, then this should not be like that. The definition has type B expression. Yeah, I feel like in order to evaluate this, we need to know how to evaluate other expressions. So we need to like have the also the function that takes A into like int or whatever. So this is function eval any or something, right? Or we can just ignore all of the issues and just continue as I was already going. But should I? So here's the problem, right? So far I have already 8,000, 7,000 lines of code. If I look at the interpreter, I mean it's relatively small here, just 200 lines right now. But this over here, this is the global enum basically, right? Yeah, and I was saying that I should have the like I should have a plugin system because some expressions or some stuff would only be possible in JavaScript, but that's also only about the natives maybe, and natives can be just extensible on their own. What is the biggest file? How do I find the biggest file in the project so far? I think the biggest file so far should be the compiler core syntax probably. Yeah, this one is like 1,200 lines of code. Because this is about compiling all the syntaxes. That is the core syntaxes. I mean, I could split that technically. Thinking about the code architecture is difficult, guys. Should we just ignore and do progress? Because I have been doing nothing for the last 1.5 hours. Have you hit a dead end with Linksider? No, but I'm not the only one who works on the project. I need other guys to do things too, you know. Also, Davey, like, remember last time I was working on the Linksider? We made the power upside down. Davey didn't like it and he reverted the thing, and then we were arguing whether we should revert it back or not. You just need your fix of levels. What? Yeah, we need to. I need to talk to Davey and tell him that we did the right thing, which is objectively good. Yeah, I agree. So yeah. Yeah, I don't know. It's very slow progress because basically no one works on the game, right? But I don't know. Like, even if I work on the game, it's not going, like, I mean, you know, like, yeah, you know, it's subjectively very ugly. Wait, what? Wait. Well, oh, Nordstrom was the other guy who doesn't like it, right? You need to have a plan. Yeah, if you need a 10-page dissertation about why that design is subjectively superior in every way. Okay. Yeah, I need to, like, just talk to the other guys on the team, that we need to make progress, because otherwise we will not release it next year either. Right? How much wish list do I have right now? Let's see. Well, I also, like, stopped doing, like, we need to like do a GIF somewhere and get more wish lists somehow, somewhere, post something, you know, do the marketing. But yeah, no one is doing marketing either. Wishlist reporting has been temporarily paused due to exceptionally high traffic during the summer sale. Wishlist reporting, including wishlists collected during the pause period, will be available after the sale has concluded. What? So I have, like, exactly 500 wishlists right now. But that is the old data, which is... So they stopped giving us the statistics in the beginning of July when the summer sale started, I guess, right? Which probably means that I maybe have, like, 2 more. Yeah, and we're over 500 now, but yeah. Align side effects for simplified feature communication in real-time environment. All right, guys, what do we do? We ignore the issues that I have. Like, if What would you do, Raymarch? What do you do in these situations? Let's take a look at Raymarch's code again. Let's procrastinate. Let's see Raymarch. Let's see Raymarch's code. What's the situation? Eventually, my Rust code base was growing, and it grew so much that my compilation time became 1 minute, right? That's why I started the rewrite into OCaml. Right? So how do I prevent the same situation happening in OCaml? I mean, OCaml obviously is like compiling faster, right? But I will still basically end up in the same situation where we'll have basically the monocrate, like thing that is able to do everything, right? That's the problem that I'm like, yeah. So like I was just talking about all these solutions, right? The extensible variants, the like this, like context generic extensible types and stuff, right? What would you do? You think you don't have as many generics? Let me just take a look. You still have like the programming language here, basically, right? So, like where expression. So you have you see, like you have every expression like this over there. So every expression can be formatted and type checked, right? So then you have expression. Wait, this is such a small one. Wait, what? Is that all of the expressions that you have? Variable, assigning, shader IO, pipeline, ref load, literal, operator. Oh, function related is like a group of things, I guess, right? Yeah, so like see, you're actually doing the same thing, but the problem is that like this is still in the same crate, right? So could you have the function related things live in its own crate so that, you know, because this right now needs to be in the same crate, because inside of the function related you are still referring to the expression because it can be contained inside, right? Probably. No? Function relating, function parameter value, store type, call, key. What's key? Shader languages are not real languages. I guess the reason why you don't hit your problem is because shader languages are so tiny. They really are tiny? I don't know. I guess they are. But like, if I look at the Rust language source code, they still have a basically. Where's the source code for the Rust C? Compiler, this one. I feel like these are still like huge crates. This still looks like a really huge crate. The problem in OCaml is that, like, in OCaml, I cannot even split a crate into multiple files, because every file needs to be like its own crate, kind of. Did check also take a long time or only build? Yes, check was taking a minute, right? Death to shading languages. in languages as we know them descend from GLSL. But I mean, the problem is not really even the compilation time. It's just like structuring the code. Like why would just like we need to split the code into crates anyway because that makes it easier to maintain, right? It's not only about compilation times. You have no parser or lexer. Parser and lexer are the simplest things. Parser and lexer, I don't need to split those. And language server is also pretty small. Like the biggest thing is the compiler and interpreter. And the fact that we have a like you know, in game development, like if you're making a game, it's very like the problem that I have is very similar to the blob anti-pattern, right? Where you have the God object, which can handle everything, right? So like, why do I have a single value type which can do everything? So in game development, you solve it by doing what? You do what? ECS architecture. Can we do compiler in the ECS style? Is that what we would do? I mean, I guess this is kind of it. I think the extensible one is looking the most like the ECS. So like, you don't think expression is a blob? Why not? It's literally specifying everything. Like, what's the difference? Because it's an enum, because and not a struct with a 1,000 fields. If it's an enum with 1,000 variants, then it's not a blob. Compile shame on your machine. I think, didn't I do that already before? Can you describe the problem in general again? I'm making a programming language, and we have an expression, right, that can be evaluated, right? An AST, whatever. So we can have like a function, we can have like math operators, we can have like this, that, all of the different variants. And as the language grows, we're going to add to it and add to it and add to it, and we're going to have 1,000 variants, which means that and it all lives basically in the same like crate, in the same library, right? Which feels wrong to me, you know? It feels wrong for the same reason as, once again, the God object in game development is wrong. Slowness was trait or generic related. I don't know what Rusty does exactly, but it's likely that. I mean, yeah. No, I mean, it was type checking. I was profiling. But yeah, I'm not talking, like, it's not just about, once again, it's not just about the compilation times. So yeah, like, I want to basically split the responsibility between different, like, plugin systems, right? Like, think, like, we made a game with Bevy, right, for example. Or not even with Bevy, right? Yeah, we want type level composition. I want a plugin system like in Bevy, right? But which would be more compile time checked than runtime checked. So it's more similar to like your library that you were working on, right? Nerdsoul. The stacks, right? But like so like the only difference once again is that, I mean, I don't even know if your library is solving the thing. But yeah, like the difference between like games. So in games you can add new fields basically to your entities, right? So you have an extensible struct. But for making a language, we need an extensible variant instead. And I want it to be checked at compile time. In OCaml, they have extensible variants, but they are not checked exhaustively. And like, let's say that I'm making my own language, right? Can I have a language which has extensible variants like this, but which also would be I'm just trying to like imagine what would it look like, you know? You write your game so differently. Well, I mean, how do you write your games? What do you mean differently? Do you use ECS? I mean, you say you don't have the global entity object? Well, I mean, technically I don't too, right? But that's how a lot of people are doing it, right? At least, like, that's popular right now with, like, Bavy and stuff, and, like, with ECSs in general. And I know that, like, before ECSs, I know that a lot of game companies were actually having the game object, even although it is an anti-pattern. Like, technically it's very practical, right, compared to like the other alternatives, because all the alternatives are what, like the inheritance, and then you like get the diamond pattern. So in order to like not have the diamond pattern on your like inheritance tree, you basically eventually end up having the god object. And then I just see the ECS as just the same god object, but being like split like at runtime kind of thing. So I don't even know if ECS is the correct way of doing things, because it's literally the god object still, like semantically. My Rust style is embrace exhaustive matches. Yeah, but like, let's say that you are making a game, right? In your game, you have like birds, you have humans, right? Birds can fly, humans can walk, right? So like you do this through the fields on your entity, saying like this can do that, this can do that. If we open the Linksider code, we will also see the same thing basically. So I have a god object in Linksider, even although it's, let me show you how it's done. You know, like in Linksider, we have all the blocks that are moving as like basically entities, and then every entity basically is configured using the field, using the properties, which is like this is over here. The entity is basically every object in the game, right? So every object can have side effects, can potentially be unlocked because it's a door on the level selection, even although the player is probably never going to be a door, right? But I still need to handle it somehow, so I have this god object which handles if it is a door on the level selection, right? You would hate how I do that? Do you have your any your game code available? Raymarch. Wait, have I even played a single Raymarch's game? I don't think I played any of your game. You have Ferris 3D and Shame. Those are the only projects of yours. Wait, do you even have any other repositories? Shame assets, shader length, specific lib, Rust game dev, GitHub IO. Their games are not public. Game Jam when? I thought Raymarch hates game jams or something. Why are your games not public? You just want to... I mean, 100 private games. Yeah. I mean, the Like, wait, if so you're wait, hold on. If you're saying that your games are not public, it means that you have games, right? But they are private. Okay, so at least we know that now, that Raymarch is working on a game that is going to be a huge hit, which is why he's keeping it closed sourced, right? Because he doesn't want anyone to steal the game idea, right? Okay, I'm waiting patiently. So the actual reason is because some of the stuff is in your CV and you want to keep online and IRL stuff separate. They're not released, it's just university projects and small things plus game jam games. Oh, yeah, I guess. Yeah. The blocky editor stuff, yeah, I saw it. Alright. I'm not doing anything. Let's continue not doing anything. Let's continue talking about the anti-patterns. Like, is there any language that actually does this in a modular way, right? Like, once again, the idea is to have the compiler to be, or like the language to be like, I think we actually want a plugin system in the compiler so that the language is extensible in more ways. Maybe we will like if I actually like figure out how to extend the language from inside of itself, right, so that we can define new semantics, new things. I also like have this idea, this very rough idea, but what if like all of the features were like then you kill yourselves trying to come up with a plugin API. Yeah, but like, I mean, in this case, for example, the plugin API is very simple. Look at this. I have already invented it, right? We just have the value, which is extensible, and an expression which is extensible. This is the entire plugin API. We just add new types of values and new types of expressions, and then we just register the way to evaluate these new kinds of expressions. Right? But yeah, so like, hear me out. Here's the idea. What if, like, let's say that the language is statically typed, right? But what is but static typing is actually like not very necessary for a language, right? Like, I could have made this language dynamically typed. What if static typing was also just a plugin? You know, what if we have static typing and now I want to have a borrow checker? What if borrow checker was just a plugin? Right? What if like all of these other parts, right? That's how I would actually want to do it, so that what if a feature is not implemented, and then I can just do it from inside of the language, like in a plugin like way like this, you know? So I was told that there is a thing that is called the model types, right? The model types or something. And I was told that in theory it's possible to make a language where it is kind of working like that. So like let's say that you want to implement something similar like a borrow checker or like linear types, then it can be done as like a mode or whatever. Extending the language sounds fun until you try to work on multiple projects with different contradicting extensions. Yeah. Oh, wait, hold on. Actually, like, there are languages with extension systems already, right? Like Haskell, or like even OCaml, right? OCaml actually calls these things extensions, right? Like if I say like this, or over here, they say language extensions. They are available to me already, but like, are they actually implemented as like a plugin system? Multiple projects with different contradicting extension. Yeah, I agree. But yes. Is there an example of contradicting extensions? Macros? What do you mean macros? Lisp is a little bit too dynamic, I think. So, I don't know. But yeah, like you know, when you're writing Haskell, you can like enable a certain feature of the language, or even like or when we're writing Rust. In Rust also they have this thing which is called feature gates, right? So you can enable a feature in the nightly compiler by opting into it, and if you don't opt into it, then it's just not going to work, right? So it's kind of like plugins already, right? But how does Rust implement it, for example, the nightly features? Anyone knows? How does Rust implement enable some nightly feature? Was it like a plugin system? Like, I feel like I feel like for these nightly features, like if I was to guess, then it's actually like each feature like this is actually present in all of the different crates somehow. And then like I feel like it's not like a standalone, but like parts of the feature are in all of the different crates basically, right? And then they need to very carefully like check for them. If I was to guess, like if I was to add right now a feature of the context, right, I would need to add this feature to the interpreter, to the compiler, to the core syntax, to the inference, right? So like the context system is like touching a lot of different parts. And before we choose C++ with a million forward declarations, because then at least we have it under control. No, I can like, I mean, what's the difference between the forward declaration and like having the global like huge enum, which is not extensible? I don't need to do C++. Attributes that are enabled nightly to chain builds. But there you recompile the whole thing with the feature, right? Not the whole thing, just a single crate kind of. So the feature can be enabled just for a single crate, right? So like basically different crates can be compiled in different modes, is what it means, right? So yeah, I mean, this is over here kind of like a plugin system. That means that it can only affect the implementation of the boundary, or it would have ABI impact. Well, I mean, no, I guess like Rust chooses the features in nightly that cannot change the ABI, I guess, because that would require an actually like separate language. So they are never doing that. The only features are like the one that don't change the intermediate representation, right? Yeah. What's dot dot? This is extensible enum. Make a small game just to demonstrate how weird and hard-coded your stuff is. Yeah. Okay. Okay. Let me think about this. So this is basically the plugin API. We can define new expressions, we can define new values, we can define a new way to evaluate expressions, and when I actually evaluate, one of the implementations must have the implementation. So like we should have at least one registered like calculator for this expression, basically, right? Otherwise we are just going to panic. So that's the only problem that I see with it, which is the runtime checked, exhaustive checking. And then let's say that I want to print a value, right? Then I will need to register printer, register value printer, which takes a value and returns option like unit and like I guess the formatter or whatever. Right? So this is going to be function f into value printers f value printers, you know, and value printers value into unit option formatter. It's ref list. So we basically maintain the list of plugins here. So this is the plugins for yeah, we can also like hold on. What if we just have like a module type plugin? So the plugin for a language. So the plugin for a language can basically extend this. Yo, T2 SDE, hello there. Thanks for the raid. How's your stream? $10,000 updates later, 85% up to date, but broken. Sounds like my code. All right, welcome guys. I am here working on programming language, although I'm not really working on anything today. At least I have not started doing any useful thing. I am considering having some sort of a plugin system in the language so that I can split the language features into separate modules easily. So I am trying to design this thing here. So Cast is my programming language, and it's supposed to be an extensible one, right? So this over here, the dot, it specifies an extensible variant type. So we can extend the values with new types of values, basically. And we can extend expressions with the new types of expressions. And I'm trying to see what would a plugin for a language do. Will the extensible one be called a reinterpret cast? Yeah, so like a plugin would basically have a value to have a to like print values, right? Wait, can a plugin specify the things that it has been extending? Can I say type value plus equal t? Wait, this is a correct thing instead of a signature. But this means that the plugin must define its own type of a value. Some plugins will only define an expression. Like, I don't need to guarantee that, right? Yeah, and yeah, and then like I guess print value is also like an optional extension that I have there, which is why maybe it's better to have like these extensions as separate functions instead of having the plugin type. Yeah, we just say register printer, register like evaluator. Hold on, module value. Just try to do that better. Type t dot. module expression type t dot, right? Okay, so expression, then we will have a compiler. So like I basically define the overall high-level structure without specifying any details, right? And then the details are going to be done inside the plugins. So interpreter can be extended with a new ways to like evaluate expression like this. And then we have evaluate impulse like that. And then we have a register evaluate. And then we have, wait, is there like a is there an extensible struct though? This would be also kind of nice. Or is there only extensible variants in OCaml? Is there an extensible record type in OCaml similar to extensible variants? No. Yeah, because like how would I initialize that, I guess? Why not? Because records are nominal and closed by default. Workarounds, yep, you can fake one with this. Roll polymorphism and polymorphic variants. Use polymorphic variants and encode records as variant field lists. You can add more fields as variant constructors. But it's not real record type, no field labels, no do not dot notation, no type safe updates. There's also objects, structural subtyping, and extensions. Oh wait, there's object-oriented programming in OCaml. OCaml objects. Can we have multiple inheritance? Inheritance virtual classes initializer. Don't forget the O in camel. Yeah. Although, like, the problem with objects is that the language server, like, really doesn't work with them, I think. Maybe that's at least the reason not to use them. Expression B is widget, means curse the button B to have type widget. My solution is to extend OCaml with a plugin system to enable cast plugin system. Just fork the OCaml compiler and fix the issues that I'm having. That's what the Jane Street did, right? With the OxCaml. Let's see. They have some extensions that are specifically about systems programming. Polymorphic parameters include functor, labeled tuples, immutable arrays. Let me actually see. Maybe they have some. Maybe I like. If I switch to this, I will see some new feature. That is good. Polymorphism has its limitations. OCaml comes with mode and kind systems which enable many of its key features, include stack allocation, unbox types, and data race-free parallelism. So like, maybe like, at least for the data race-free stuff, Maybe I could switch to this one. You know? The implementation of these two functions is obviously identical, so it would be nice if we could just write it once. Immediately we've written a preprocessor to do exactly that, ppx template. Much like templates in C++, this allows us to define the function once, polymorphic over some mode variable, while the compiler will instantiate. Okay, they have templates here, like in C++. Nice. Instantiation. Kinds. Modalities. Floating attributes. Custom error messages. You can put the error message attribute on type or kind constraint to add custom text to error messages, useful when writing a preprocessor. The immutable arrays extension. Immutable arrays are just regular arrays, but they cannot be mutated. Okay. The include functor extension eliminates a common source of boilerplate when defining module that includes the result of functors. I think I actually wanted that. Hold on. Include functor comparable make. Traditionally, this would have required defining an inner structure T just to have something that functor can be applied to, right? Maybe it's not that necessary. No, module strengthening. What is the type of module M in this tiny program? Module type S, sig type T end. Module MS. If you said S, then you are only partially correct. We only also need to keep track of the fact that all of the type declarations inside of it come from M. So the type that the compiler infers is actually stronger. Signature type T is M.T. We call this type S strengthened with M. It can be written out explicitly as above, right? In fact, is the only way to write it without extension, module strengthening. The new extension allows to be written as S with M. The main motivation is compiler performance improvements. Maybe polymorphic parameters, just sugar. I mean, it's kind of sugar, but like if there is a lot of things, then it's there is a lot of boilerplate, I think. I think I have actually been like hitting that over here. So I'm defining like some recursive modules, and I need to specify the signatures, and the signatures contain all of these, but this over here is technically just copy pasted from another place, which I cannot include. Maybe it would solve it, I don't know. Tracing probes. Tracing a common native program is user space. Tracing probes can be defined at common extension points where name is string literal. Probes is like for profiling. Small numbers, int 16, int 8 types. Zero allocator checking, to compile time checking for all non-allocating functions. So you check that the function is not going to allocate memory. Yeah, I mean, I don't care about that low-level stuff, though. There's SIMD. Comprehensions. What's comprehensions? List and array comprehensions. Seen like in Python. I don't know if that's needed. Uniqueness. Yeah, so this is like the linear types. Yeah, they have linear types here. Unique mode designates values that have only a single reference pointing to them. If an operation takes any unique argument, it will consume the only reference to the value. I wouldn't say that I have really wanted that though so far. It's nice, but also whatever. Capsules. Data that lives in a capsule is represented by the type capsule. A capsule is a collection of mutable state accessible via a particular API that prohibits data races. Capsules may be associated with locks, which allow their mutable state to be shared across domains. So just like a mutex, kind of. Why do they call it a capsule? And then you have capsule access. Which is more like the lock guard, probably. Password represents permission to access K by making it the current capsule. Prohibit access without taking the lock. Yeah, I think this is like, yeah, they are trying to have the features for the fearless concurrency, similar to Rust. I think this is similar to just the way Rust does the mutexes. I mean, they have the mutex here, which is separate. Anyway, I don't see anything that would allow me to do the plugin system easier, so let's see. So we are going to have a value T, which is extensible, expression T, extensible, compiler. We'll have something, interpreter. We'll be able to register the evaluator and evaluate. Value, we'll have the register printer, which is T into unit option, right? Formatter, T is unit option. Or should it be like T into optional formatter unit? Kind of this thing, maybe. Because I want to pattern match immediately and see if I can handle this value specifically. You know? So, printers is formatter. List ref. Like that. This is function f. First f. First. So like literally the same as registering an eval. Like that. We can change this to a type. Or I guess print function is this. And evaluate is basically register eval. This thing over here is going to be eval function. Evaluate function is expression into optional value. I mean, technically though, it would take the state, right? So the interpreter will have the state. Type state. I don't know, T, right? So expression into T value option, something like that, right? So in order to evaluate, I need to give it the state of the interpreter, the expression, and we will get the value back. So we have evaluate impulse, and we're going to map f using f expression, and then an option get, and then we apply that function using the state like this. Why play? I'm just playing around, right? I'm just trying to come up with a thing. I'm not, yeah, I'm not actually touching the cast code right now. There was a language feature that I was going to suggest call it clay. Okay, so there you go. So we have basically, so this over here is defining just the thing, the cast itself, right? We are defining the cast itself. It will have values, expressions, compiler, interpreter, and then we have a plugin, right? So this over here, like int plugin, or whatever, right? Module plugins is this. So we have two plugins, integers and add. So integers are defining the new values. So value can now be an integer, right? And module add is defining a new type of expression. Is that a feature that could get you clayed? Okay, and then we do cast interpreter, register the function. So this would return some eval. Type expression is side expression t, right hand side expression t. Like instead of just inline this here, I'll say this add expression, add expression, then we say some evaluate expression, right, like that, and then we'll have eval, which is expression into cast value is no, it's expression into cast interpreter state into cast value, right? Function function, we have left hand side and right hand side. Okay, looks like it's kind of working here so far. So then we just need to make sure that yes, over here we'll just match left side and right hand side. These must be values that we recognize, right? So this should be, so this add plugin depends on the int plugin, right? That's why we said type cast value e plus equal add, which is equal to int, right? So over here I say if it's int a and int b, we will return int a plus b. And if it is anything else, then we will return fail. Can only add ints. Oh no, this one is expressions, right? Yeah, we need to have like left-hand side is cast interpreter. Yeah, this also is function expression into interpreter. So then we say cast interpreter evaluate the left-hand side. See a lot of people programming with OCaml. What do you like about the language? I have background in Rust and Python. Well, I don't like Python because it's not typed. So, like, I don't like having bugs in runtime. So if you can't, like, static typed is better than dynamically typed, basically, right? And then it compiles faster than Rust. Even with like the type descriptions in Python, I feel like Python is not really there in terms of preventing bugs at compile time. And here I am doing the thing that is going to actually panic at runtime. Everything compiles faster than Rust. No, not everything. Haskell compiles slower. And C++ also compiles slower. At least in my experience. I guess it depends how you write your code in both languages. Zig also. No, Zig is compiling faster than Rust. What do you mean? Although I never tried a big Zig project, I guess, which uses a lot of like comp time evaluation. This should be like int. Okay, so this works. So here's what happens, right? Yeah, and also over here for the int, I can like I can say cast value register print function, right? Which can know now how to print these things specifically. So if we have an int, and if we have anything else, then we'll see none. But if we have int value, then we're going to, you know, print value. You say you see a lot of people writing OCaml. Who is the other people? I am very rarely seen someone else writing OCaml on Twitch. Yeah, C++ compilation isn't that bad if you like coffee and sword fights. Yeah, I guess. Yeah, I guess. Yeah. It does get a bit annoying when you're trying to do something urgent and accidentally touch a header and it's 2 a.m. already. Yeah, that's basically why I stopped Rust. I mean, technically I could have continued, though, yeah, with Rust. But once again, I was having really slow compilation times, and every single feature that I added to the language was increasing the time. So, like, the more I work on the language, and the compilation times were growing really quickly. You know, that's like part of the reason why I'm trying to come up here with the plugin system, right? Because, like, let's say that I would do the same thing in Rust with a plugin system like that. It means that I would be able, like, that's how I would like split my code into multiple crates, and that's how you like speed up Rust compilation, kind of. Togglebit did some OCaml. Wait, Togglebit did some OCaml, really? I didn't see it. When did he do it? Like recently? Togglebit, TJ, and Prime, yeah. But this is just 3 people. You say a lot of people. That's not a lot. That's just 3. Well, now it's 4 because now it's me too, right? but this would speed up the compiler compilation time at the expense of cast program compilation time. So this over here, this specific solution is doing it through the runtime system, yes. But at the same time, like, how does pattern matching actually works? How does pattern matching actually is implemented in the OCaml? When you say something like this, type foo is A or B or C or D, right? And then you say that function foo is taking foo and returns, like, I don't know, unit, right? So this will be like match. This will be like a function that in case of A does that, in case of, you know, B does that. Do we actually like have jump tables or something like that in the implementation? You know? It must be lowercase. You know? So like, instead of having this, we're basically saying something like this. Type u is dot dot, and then we say like and we say like this, type u plus equal a, and we say type u plus equal a, and then b, and then c, and then d. Like, technically for the type itself it's still the same, but then we specify the function which takes u and returns unit. It's no longer doing the pattern matching. Now it is basically going to say that, you know, it's basically a bunch of ifs. It's basically like if you know, like, it's something like this, match, you know, yeah, okay, function that into match this with I don't know, let's have this, handlers is a list, handle A, handle B, handle C, handle D, you know, and then this is going to be basically handlers into list, find map function into list, find map function f u. Yes, option get. Like, that's literally what I'm creating here, right? And then for every single one of these, we specify the handle function, which is function. If in case if it's a, then we return that, and in case if it's anything else, we return none. So like, literally this being copy pasted like that. Like, but isn't this kind of the same thing? How much runtime overhead is this adding? Why are you so bad at coding? My bad. Everyone in doing OCaml now on Twitch. And YHT, hello, hello. So yeah, like, instead of having just a single pattern matching like this, we basically say, try pattern match with A, and if it fails, then try to pattern match it with B, and then if it fails, then try to pattern match with C, and then if it fails, try to pattern match with D. But isn't that like what pattern match is already? Isn't this just like a bunch of ifs? If this is A, then do that. If this is B, then do that. If this is C, then do that. If this is D, then do that. It's kind of the same thing, but it can be like compiled into like a little bit differently, I guess. It's just like a little more indirection, right? So like, there is a little bit of the overhead. But what if these functions were actually inlined, right? Because this function, they can be inlined, right? And if they are inlined, then this can be basically compiled to the same thing. And then we basically say over here, option get, this is saying that we have basically a default branch, which is just going to like panic. Non-exhaustive. Right? So, and then that's where the other difference is that this, because this is extensible, this cannot be exhaustive by, like, we cannot do exhaustive checks at all. So that's like the only difference. But yeah, I don't know. I feel like it shouldn't have too much of the overhead though. Not sure if it can be inlined either. Why not? Is the compiler stupid? I feel like it can be. Like, why wouldn't it be able to do that? Can it inline at least find map? Because like in Rust, it can be done, right? So why wouldn't it be possible in OCaml? Even in Rust, if you have an iterator and you like just iterate, it's going to like be a loop. And this is like a loop with 4 ifs, kind of, right? And so it can also replace the loop with like... I mean, I guess technically this is like a loop still, right? Because this is like a value. It's not going to inline this value, probably. Yeah, I don't know. I feel like it's not going to be too much of the overhead, though. Even if there is... the find if will be inlined. Maybe with unknown size, so no jump tables, etc. Would it be better to create a factory method? Okay, hold on. We have some new choices. What's a factory method? What do you mean by a factory method? Because this literally is a factory, kind of, right? So we specify how to construct the handler for this, right? This is not, yeah, because this can return a function which actually performs the handling, if we have like some associated data here. A class that creates methods in return functions. Yeah, I mean, that's how I'm doing this here, actually, right? So, for example, right, I'm registering a printer for the integer value. This returns actually a function that... Okay, well, I mean, I'm still, like, capturing the value here, right? But, yeah. I feel like to use, like, the factory stuff. Let's have it with just 2 variants here for now, just to make it easier to try this idea. Sure, let's try factories. So basically, I'm going to say that we have some data associated. So like A of int, for example, and B of string, right? So I want to just like have a function that prints this thing, right? So print is a function which takes this. In this case, it's going to say printf just the string, right? And in this case, it's going to print the integer, right? That's the difference. This is the simple one with just no extensibility. And over here, it's going to be extensible. So this is going to be a create printer of A, right? That's what you say. We need to have a factory that creates the function that actually prints the value. So if we have, yeah, that's why I'm saying this. If I have an A with this, so this should be a... But you mentioned you also have multiple handlers for the same type. Will they run in order? Wait, is the intention to have the plugins selected when you're building cast compiler, or to be able to dynamically select plugins when compiling a cast program? I mean, I think both. I think both. Well, I mean, I want to basically compose the compiler out of the separate plugins, right? And potentially have a runtime addition of plugins, so that if I can figure out a way to write a plugin from within a language, so you can extend the language from inside, right? You know, we have already extensible syntax, right? But I don't have extensible, like, other parts of the language. I only have extensible syntax right now. And like a plugin system like that will allow me to extend more of the language from inside of the language itself. I could have a fixed inline list with an optional handler for extension handler picked when compiling a cast program. The fixed part would optimize nicely. Yes, but I don't want to construct this list in some specific place, right? I want to register a plugin like over here, right? Because I want I don't want, like, when I write the plugin that handles addition, I don't want to add code all over the place. I want all of the code about addition to live in a single place, right? Because otherwise I can just like have the global enum like that, right? That would optimize nicely, sure. But that's literally what I'm trying to not do. To instead have it composed. Right? So I say create printer of A. If I have a of int and B of string, right? So create printer of A is going to say that I create a function that prints it. Wait, I don't know, like how like what does it mean create a function? When would I use the factory is the question. Right? Because I need to still dynamically select. Like this is basically the dynamic pattern matching that was happening before. But it could use an existing function, right? But I don't know if like factory can be applied here at all. You still have a register plugin function and a single type map. You still have a register plugin function and a single type can map to a list of handlers. Yeah, that's what I have, right? Yeah, no, I have. Yeah, let's just get rid of these examples, whatever. Look at this, I already have it. So I have a value. Value can register a printer, right? So this is a plugin. So when you have a plugin that defines a new type of value, you will register a printer for this new value, right? So I have a single list over here stored in this variable. Right? Goes up. Hello? But this is not a constant. So if it's not a constant, then it's not going to be inlined, right? Because this is a runtime thing still. I don't think I can make this to be a compile time. But basically it's the same. Like in OCaml, this system is already being used. It's literally being used already for exceptions. If you define your own exception, then you want to like specify a printer for it, you just register the printer for your exception. So like that's how they do it already. So I feel like that is the way. I guess we can see how do they do that. So they have the function, it's called print exception register printer, right? I can take a look at the thing. So there is atomic get printers, right? Yeah, it's just like atomic. The only difference is that it's atomic, so it is working with multi-threading, I guess. So maybe I should have atomic instead of just because normal reference is not like atomic. Atomic. Yeah, this is like atomic references. Maybe I should do that. Atomic make. Wait, you wrote language in OCaml? Yes. I have rewritten language in OCaml. Not the entire thing though, but we have a lot of new features. If you are coming back, let me show you. I have the new playground, which is more powerful than we had before. So this time in the rewrite, I have been focusing mostly on the language server features, so that we can have things like inlay hints over here. So this is not shown. This is actually an inlay hint. I can have hovers for the types that have been inferred, right? I can go to the definition of things. I have syntax highlighting. I have like all of these features of the language server basically, but the language itself is smaller than before because I have not rewritten it fully. So I'm thinking of the plugin system before the language grows more, so that it's going to be like more manageable. Like, you know, just thinking about the architecture a little bit. So procrastinating, in other words, is what I'm doing today. What's the experience of Camel versus Rust? It just compiles like 1,000 times faster. That's the experience. And other than that, I guess I don't really like need to worry about the details such as like boxing inner stuff, right? So because everything is boxed by default in OCaml, I don't need to worry about that. So it's a little less boilerplate, but there is like no borrow checker, so we are free to do stuff. But at the same time, it means that it is easier to write bugs in OCaml, which means that you don't actually want to use mutability, and you want to write it in functional style, which like leads to like different way to code, basically. Is using LSP protocol? Yes. Yeah, I have a this over here is in the browser. This is using not exactly the LSP, but I'm using the Monaco editor, which is the same editor that is in VS Code. But I have the plugin for VS Code too. I have plugin for VS Code too over here, so that in the VS Code I also have all of the inlay hints and go to definition functionality. This is like through the actual LSP. But once it compiles, it works, right? That's your impression from SML. What is SML? I mean, it depends. Like once it compiles, it works is like true in comparison, because I don't know. I feel like the language that does it best maybe is I mean, like I think Rust is doing it better than OCaml. If it compiles, then it works thing, and then maybe like Haskell does it better than Rust in some parts at least. Maybe like not in all, because Haskell doesn't have the borrow checker. Although Haskell does have linear types these days, so I don't know. And then there are languages with dependent types which go even further and like are even better in that sense. But I have not really written much of those. Like, for example, your function still can raise exceptions, right? So even if it compiles, you can still have unhandled exception. That is not handled, right? But there are languages that can do that. Like you can, for example, in Haskell, instead of throwing exceptions, you can use the monads. In OCaml, you can also write the functions in the monadic style, but it's more annoying than in Haskell, I think. But there are, and like for my language, I'm going to try to make the effect system. There is not a lot of languages with effect systems, but there are some which are going to like catch that stuff without like needing to rewrite your code in like the monadic style. You know, like in Rust, if a function can panic, I cannot know that. It's only documented. Like I need to read the documentation, which is not guaranteeing anything statically, right? Because I'm just going to ignore reading. OCaml doesn't have like thread safety, for example, compared to Rust. And I have had bugs because of that. As soon as I started using threads, the first thing that I had was a bug with multi-threading in OCaml. When I was trying to make my my LSP work in the background while I'm typing the code. And the documentation has to be updated, yes, which will never be updated, right? The code documentation will stay out of date. Well, I mean, people in Rust, they are doing like good job. In Rust, people at least like for most of the libraries that are widely used, they really try hard to document the like unsafe blocks, right? And like panic and yeah, and like panics are kind of documented. But like if a library is being updated and it's changing the these like implicit requirements, then you need to like detect these changes, right? If they are only present in the documentation, you are going to have a bad time. In Rust, do people use pointers? I mean, yeah. I mean, you use references mostly. But sometimes when you implement something low level, you can work with pointers too. I have been mostly writing safe Rust, so I have not worked with pointers really. But if I cared more about performance, then maybe I would. But I was instead like using a lot of reference counting and interior mutability, which is like the ref of OCaml, for example. Okay, what am I doing? I was doing something. Yeah, so like, yeah, okay, so we do that. Printers, print function, unit function f, printers is f and printers. Oh yeah, and this should be, so this is now atomic. And if it is atomic, then I should say atomic set. Atomic set printers to be f and atomic get printers, right? I don't know, like, if does atomic even make sense here? If like, does OCaml actually initialize the code in multi-threaded way? Because registering the printers are going to happen in like the initialization of the modules, not so, which is like basically before the main function, right? Is this multi-threaded in OCaml at all? I think not, but I'm not sure. Okay, so I have print value. T formatter unit is function value fmt and f and d like this. So this is the entire example here, right? So we have two plugins which defines the integer type and which defines the addition. And addition plugin depends on the integer plugin, because that's what we add. Doc tests help with that too. Not all of the documentation can be tested. Like, for example, how do you test the unsafe documentation in Rust? Not other than say, but keeping up with the date in general with the code. API changes, test fail. But how do you know if the API has been changed? That's the issue, right? If the API is only like part of the implementation detail, right? If a function panics, or if a function does some like is an unsafe function that like needs to do it in a certain way, then the only API is like then the contract is only specified in the documentation, right? So how do you detect the fact that the API changes there if you forget to update the documentation? The quick search suggests modules are loaded and initialized one by one in order to appear. Yeah, I think it's we don't need atomic, but if we do it in runtime, then we might want to do that, I guess. I feel like this is not a big overhead, since this is like, anyway, it's like just once before the main function. It doesn't matter. We can use atomics, we can use references. I guess it doesn't matter. I mean, they run as tests, so if your API now panics under the hood, the doc test would fail, no? Well, I mean, yeah, but it only panics in certain uncertain conditions, right? So you need to have a test that catches that condition. Like it's work compared to it being checked at compile time, which could be done, not impossible. Like compile time test is the best test because you don't need to write it. Like type checking. Okay. Do I like this? Let's just try to rewrite the entire thing, maybe. So basically, I will have the cast. So the one that defines like the plugins like this, right? Like literally this thing needs to be present in its own library, which I guess we will call the core, maybe. Maybe? Is it the core? The one that doesn't like have anything in it, basically? Is just the core? Maybe I will have some like basic types there. So cast core, you know? And it will have all like all the plugins there. And then I just need to load all of the plugins from like the library, right? So we will have a thing like this, right? So that's what we had previously. We had like compiler and interpreter, and those are like the big modules, right? And now we want to split the logic differently, where we have like I don't know, math and like the different features of the language into their own like plugins. And then we combine them into the single library, but all of these depend on like the core. So that's like the structure now, right? And we can, yeah, instead of like these two growing infinitely, we will instead grow horizontally here with more plugins. And these plugins can have like dependencies on each other, I guess, technically, if needed. So cast core. It's a library. Okay, and then I just move all of these things here. Okay. So it's mostly, once again, just about the interpreter and the compiler. And also like the inference, I guess. Right? So like when I define an integer, I will define like a new value, the way to like, or like, yeah, we will also not only having values and expressions and compiler, we will also have the types, right? So we will need to be able to define the new types. We'll define printers for types. Expressions also need to be printed, probably. Which means that, by the way, should I not copy paste that? I should probably not copy paste that. I should say module print is the thing where I have module make. Make for t. And this is going to be like what? Like TT. And module type T as a sig type T and that. So inside of a value, I will include print make t, which means that I will have module t struct type t is t, type t is this t, type t is tt. Is that how you write a camel? That's literally what I was just looking at in the ox camel, right? The what? The include functor, right? Include functor extension eliminates the common source of boilerplate when defining modules that include the results of functors. So we will just include the functor comparable make, which uses the current one, right? So comparable make needs an inner structure t like this. Yeah, and then we just include t. Yeah. That's literally what I'm making here. And I mean, they all look the same, right? If I don't initialize with them with any, then we just like, because I want to be able to print everything. I might just like, you know, the functor doing all of that. All right, whatever. Good enough. So we have interpreter. Interpreter should be able to evaluate expression. Also, we need to have different kinds of expression, by the way. We should have a GADT here, because I have expressions, I have assignee expressions, I have type expressions, I will also have place expressions. Maybe patterns is also like another thing, but patterns are not really like the ones that I evaluate, I guess. Yeah. I think we should have like expression type T. This one should be a GADT. This one should be a GADT. Just include T here, right? So this one is print make T, but this one is print make a GADT one, right? It's a little different. It's a little different, right? Which means that I need to have a type GADT. So I have T, which is GADT, and this one is like a GADT, like that, right? So we have a print function, which would take the which is a function that should work for all of them and return like this. But this cannot be stored in a type, so this should be like a print function which is like that. Wait, is that possible even? Make GADT. Is that even possible? Oh, by the way, I forgot about the actual print function. So actual print function here is going to be, you know, T into formatter into unit. No, actually it's going to be formatter T unit, right? Because that's the convention. FMT value into atomic get printers into list find map. Find map function f value into option unwrap or else function fail with non-exhaustive I feel like I just want the line of code here. This is like the programmer error. I want to know this line. Hint. This function application is partial. Maybe some arguments are missing. That's what we want. Okay. And it's very similar. In the evaluation too, I guess. I think this one should be an expression into state so that I can pipe into it. Maybe this can be used to compile some DSL, like a shader language. What's this? Like generically, this approach. I mean, I'm making a language. It could be used for any language, I guess. This approach, including shading languages. In fact, shading languages is going to be on my to-do list too. I do plan to transpile to shading languages. My language. Okay, let's not worry about the interpreter for now. So how do I make a GADT one, right? So we have the type, which is a GADT, and I want to make it be printable, right? So the printers that I store, the list, I store the list of the printing functions, right? Which technically should be like for all a print fn. Can I do that? Not really, right? I need to store it always in the in a data structure. It cannot be an argument. But if I make type, you know, but if I make type print, yeah, I guess we have a type print function, which is like which actually has the function f inside, which is this, which is works for all a's, right? Then I can do it. That's right. Like it needs to be like the inner field of a record, because otherwise like it doesn't work. Would you then have to specify a backend as part of the plugin? Plugins extend the language. Like interpreter that I have here is just one of the targets, but interpreter is a target that I must have. The other targets, like the shading language, is an optional target, and that target technically should even be implemented inside implementable inside of the language itself. Is the idea, because you should be able to basically inspect the compiled code, and since you can expect it, you can generate code based on that. So that's how like you kind of write a compiler inside of the language. I don't think that's has to do with the plugin system. Although a plugin can have like the transpiler to like a shading language to be a part of the interpreter, because the way I'm doing the compilation, we have the idea is to have compiler as a library basically. So when I'm interpreting the code, I can call into the compiler that will generate the compiled thing, right? So that means that the compiler is part of the interpreter. So we can have it as a native thing, or I can implement it inside the language itself. It's like the idea. I had the prototype of that working. I was transpiling to JavaScript before I started the rewrite to OCaml. So yeah, I have this. If you have not seen, the idea is over here. So you should. I want to be making games, right? So inside of my game, I want to have the shader, right? So GLSL, but I don't want to actually write the shader in a different language. I want to write everything in a single language. So I want to just transpile to GLSL, and this thing is a const. So this thing is going to be evaluated at compile time, right? So we have compile time evaluation like in Zig, right? And during the compile time evaluation, I have this interpreter, and interpreter would be able to know how to transpile, whether this transpiler is written in the language or it's like embedded in the interpreter is like two different variations. Const is like const expr, yes. Or like in Zig, you would say like comp time or something, right? Yeah. Yeah, so this is just literally evaluating code at compile time. And so which means that the interpreter is the one that is actually doing the transpilation. And then similar to that, like your basically build script is a very, very short script which just builds the executable, for example, right? Or we can have a transpiler to C or whatever. Yeah. In this rewrite, also the current idea is to start with a transpiler, but not to JavaScript, not to shading languages, but to actually transpile my language to the OCaml. And the reason is that I want to eventually rewrite the language in itself, and by transpiling into OCaml, I will be able to use I will be able to rewrite the implementation partially. And I will just replace some existing OCaml source code with my own source code written in the language itself. That's also something that might work very nicely. OCaml is a simple enough language so that I can transpile to it easily, I think. And then OCaml already knows how to transpile itself to JavaScript. So I can do that way too, and OCaml can compile to the native targets. So by transpiling to OCaml, I basically already support the web and the natives, kind of, I guess. Okay, so here's the printers. Printers is this, right? So when I register a printer, I should register a print function which is generic here. So this one. But I cannot have this as an argument, is the problem, right? Wait, hold on. I'm actually wondering. I mean, we don't do this for the effects. The only GADTs in the OCaml standard library is the effects, right? I think the exceptions are not GADTs. And for the effects, we don't register like a printer or anything. Okay. Yeah, so I will have to like wrap it into a field because like what's this feature even called? What is this feature even called? Existential types? No. Explicit naming, existentials. Equations for non-local abstract types. I don't know what's it called, but you can only store a polymorphic value inside of a field. I guess it doesn't have to do with this, right? OCaml store polymorphic value. I don't know whether it's documented. I just want to see if I'm wrong. Maybe like just let's ask ChatGPT. How to store GADT in a list. Camel. Let's say you have a GADT like this. This thing is typed differently for each constructor. So you cannot just say that we have a list like this. Compiler goes nuclear. Fix the wrap with existential type. Pack. Yeah, we need to like pack. Yeah. It can be like not a field. It can be like the constructor. Wait, packed expression is pack. Yeah, this is like implicit for all A's, I guess. ChatGPT surely replies weirdly to you. Yeah, a little bit. Print function. I think we can just say that over here. Print function. Print function like that. Yes. Constraints are not satisfied for this type. What? Type formatter unit option should be an instance of print function. Oh no, hold on. This is not GADT. I want like this parenthesis, but this doesn't work. No, I think ChatGPT just lied here. Like I need this to be a field specifically. Like so the problem. So I'm storing the polymorphic value here. Right. So this value has some type, but we don't know exactly what type. So the field can store all the types. So we must do it through the interaction like this. Okay. Anyway, so we have a print. Yeah, and but I think when I register the printer, I cannot. Okay, fine, whatever. Like because I cannot have an argument which is polymorphic value, right? Can I? Can I have polymorphic value as argument of a function? Like it's supposed to have higher counted polymorphism, right? For that to be. So yeah, apply twice is a function that is polymorphic. Yeah, it's a single type with polymorphic fields instead. So yeah, this one is generalizes the idea to be monomorphic. They fix explicit polymorphism. Apply twice, type A. Boom. First class polymorphism with dot syntax. F, like, is this actually working though? I feel like this is not working. I mean, let's try. So I have a print function. This over here should be for all A. ATT into formatter into unit, right? But this is not correct syntax. So ChatGPT lies to me here, right? Yeah, this is not correct syntax. You cannot have an argument like this. This works in like Haskell though, right? Arthur CO3. Yo man, I'm the guy who referenced you in my final project essay. I gave my presentation yesterday. They said it was the best final project they'd seen. Unfortunately, I didn't get the chance to blame you. Next time I will promise. Oh, nice. Wait, you referenced me because what? I forgot about that. I remember that you asked me, but I don't remember why. What did I do? What did I do? You say you didn't get the chance to blame me, so you just referenced me without, like, actually referencing me? You told me to compile to JavaScript? Oh. My bad. So I cannot have a polymorphic function as an argument of a function, right? OCaml higher kinded polymorphism. Higher counted bounded polymorphism. Why a higher counted polymorphism is not directly supported in OCaml? Hard-coded type variables are not supported in OCaml. Explains why. In a word type aliasing. For completeness, we recount their explanation here. Hard-coded functions and as functors. Comes the module signature. Lightweight hierarchical polymorphism. None of this is from the OCaml. Polymorphisms and its limitations. Higher rank polymorphic functions. Explicit polymorphic annotations are, however, not sufficient to cover all the cases where the inferred types of a function is less general than expected. Yeah, over here, right? Average is for all A. Yeah, this over here is higher kinded. Note that this syntax is not valid within OCaml. Average has a universally quantified type inside of the type of its argument, whereas the polymorphic recursion, the universally quantified type, was introduced before the rest of the type. This position of the universally quantified type means that average is a second rank polymorphic function. This function of this kind of higher rank functions is not directly supported in the OCaml. Type inference for a second. In OCaml, there are two ways to introduce this kind of explicitly universal quantified types. Universally quantified to record field. So that's literally what I did, right? In order to have the higher kinded polymorphism, we need to store it inside of a field. And universally quantified object methods. Okay. Yeah, okay. So like basically this is the only way, because fuck objects. That's specific to recursion? No, this is not specific for recursion. This is literally when I want to have an argument which is a polymorphic function. I cannot do that. I need to store this function inside of a field of a data structure in OCaml. In Haskell, I would be able to just have it, but we're not writing Haskell. In Rust, also, I would not be able to do that. In Rust, we don't. In Rust, I would not even be able to store that. So there is even no alternative. So OCaml technically better here than Rust, I guess, at least. The argument in the explanation sounded specifically to recursion. There was something like over here. There was something about the recursion. Polymorphic recursion is just a different thing. Is a different section. Recursive functions cannot be like inferred as polymorphic or something. You need to explicit type annotation. So register print has the print function, so I will need to store it inside of a field f. Okay. Okay, so print has the formatter. So print is actually the function that is itself polymorphic. So it works for all a's. We have formatter and then at and then unit, right? So we are going to get the printers here, and then we're going to find map. So f is not going to do the value. We have f.f here value now, and that's like by doing this interaction we can do the GADTs. All right, nice. And then similarly, I'm going to have the evaluation. So my expressions are also going to be the GADTs, right? Because once again, we have type expressions, value expressions, place expressions, assignee expressions. Actually, not all of them even can be... wait, hold on. Assignee expression is not even evaluatable, right? Assignee expression is more like a pattern. So maybe it will be like a separate thing. Or is assignee expression something that I need to evaluate still? I don't know. Anyway, so this is a GADT because we are going to specify the result type after evaluation there, right? Yeah. So we have a evaluation function which is going to be f for all a expression. No, so this should be an expression of data A into B. Or not. Wait, what? How do you do GATTs again? AB? So this, since this is like as an expression that is of this type. Assigning expression is not a normal expression that has a value. No, I mean like the left-hand side, L value or something in C++, if you are more familiar with that. Maybe. Like, because when you say like A and B is equal to like 1 and 2, right? For example, this over here is an expression. I don't actually calculate the value of A and B, right? But this is like it's very similar to a pattern, but it's like different, you know, because it assigns to existing variables. So we have a dedicated assigning expression for that. Or we can always like have just assignment to a single variable, in which case we would not need the assigning expression. But since we want to have like destructuring assignments, basically, that requires like this having a dedicated type of expression. Right? Like it's different, so you can say let A and B be equal to 1 and 2. This introduces the two new variables. In this case, this here is a pattern. But if I modify, if I mutate, for mutation, A and B is 1, 2, this is going to be a assigning expression. This is a pattern, this is expression, this is assigning expression. And then there's also type expressions. If I over here say, you know, like int32 and string, for example, right, with 1 and 2, this over here is a type expression, this is an expression, this is a pattern, this is a assigning expression. Left side could also be the result of a macro or maybe plugin extension in the worst case. Yes, that's already supported through the macro expansion. Yeah. I mean, I think it is, yeah. Should be. Okay, so when I evaluate, I say it works for all A's, like this. A, B. This is returning B. So like the evaluation does not necessarily return a value, right? It might return... So the return type is dependent on the expression here. A, B. Expression state. Evaluate impulse, find map f dot f expression. And then we, in the end, we call f, we're using the state. There you go. There you go. Okay, it compiles. Okay, so we have types. Values should be able to know about the types of each other. Values should be able to know the types of each other. Does it mean that values should be defined after the types? So we know what the types are, now we can define the values. So so value should have the type. So we have we'll have like the type of, right? The type of, which has a value and returns type, right? Yep. So this means that I also need to like register the value types.
Let's see, type of impulse, right? Type of function, list, register type of impulse, type of impulse. Wait, is there like an atomic update or something? Atomic update. There is a fetch and add. This is specifically for integers. Make contented, set, exchange, decrease, compare and set. No. Also, since I'm getting like, isn't this actually the incorrect code? If I do get and then set, then someone can modify this in between get and set. Isn't this actually incorrect? I need over here to do compare and swap, right, with the original value. If I want it to be actually like correct code in multi-threading. Type of function is the function that takes value and returns optional so type of, we're going to get the type of impulse. And then we are going to call the function using value, and then we return that as is. Okay. So when I define a new value, I need to like also specify what is the type of it. Can I have over here? Maybe I can have one over here just so that I like don't forget to register the things. I should have like the module type plugin, the plugin for a value specifically, right? So my plugins are going to consist of a plugin to a value, a plugin to an expression, a plugin to like compiler and interpreter, right? So whenever I define a new kind of value, I need to remember to say what is the type, right? So I need to say type t plus equal like t. So like this is the plugin type, I think, right? Is how this works. And then so the plugin should extend the value with a new type of a value, and then it should also say what is my type of function. Type of is a function that takes maybe I should also have like type t, which is like the inner value, right? And then the new variant, and type of says t into type t, like that, right? And then we also should have the value print, which would have a formatter into t into unit. And then actually like the formatter that is doing that would be automatic. So I can have basically I can have basically a function register plugin which has the module plugin argument and returns unit, right? Hello, Ogma. So this would be a function module t into, right? So basically I will register a print function using this print. So I register a print function using function, and if it is of type p.t value, then I will p print I will have a function fmt into p print fmt value, like that. And this should return like sum. And this, in any other case, will return none. Because that kind of makes sense here for me. So register plugin is doing that. And and in addition to register a printer, we will also register the type of, which will be also similar, function. And if I see the value of this thing specifically, then it's going to be sum p type of value, right? Semicolon score. Okay. So yeah, if I need for some reason, I can do this like separately, but it's better to like use the register plugin function, I guess. Okay. Register plugin for the expression would need to define how to interpret it though. So I feel like I'll need to redefine the expression later. Okay. So let's see what do we have. What do we have? So here's all of my values right now, right? We have units, booleans, integers, strings, tuples, types, functions, native functions, ASTs, unwind, tokens, and errors. I feel like error should always be present though. Like I feel like error is belonging actually into the core. Yeah, I feel like error belongs to the core. But maybe I can have it as a plugin that is just available here. Always. Also, is it worth to split this into files? Not sure. Let's just head over here for now. So module. Yeah, so I'll have module error. Right? And error. We will have the error value, we'll have the error expression, error AST and stuff, right? Error type. So I guess we will have an inner module value. So error value type T is I don't know, unit, right? So I will have yeah, yeah, we'll have like the module plugin here, which will be of type value plugin struct end. So we need to define what's the type T. We need to say type of value value T plus equal you know, T which is error. I mean T of T. I guess I just do that. And we have a print value, which is T. For matter value unit is, we're just going to say fprintf mt error, like this. using red color. And then we will have a type of value t into type t is, so like what's the type of the error value though? I feel like I can yeah, I don't know.
Hello Santi mods.
I will have the error type for that, right? Hello Santi mods. Type value t plus equal plugin t plus equal t is plugin t. Type t is plugin t. I mean, I should just yeah, you know what? I will just include. Maybe this should just be value. So this should be like type plugin, actually. Yeah, this should be type plugin, and this over here should be value plugin. And type of will just return type dot, and not this type. Is there like a way to have like the global namespace or something? You really like Chilling Cider, Senti mods. Hello, thanks. Thank you. At some point we will release the full game and you will be liking it even more, hopefully. There's a lot of other features that are not in the demo. You can see some of them in the trailer, like portals or magnets or gravity changing. Let's have type plugin. Register plugin on the type too. So type plugin is just not going to have the type of. We are only going to be able to print it like this. Okay. So this should be type t. Okay. Yeah, so this is like under the hood is just unit. And so value should say, so this should not be like I want to like refer to different like types, you know. Can I refer to like the this one if I have shadowed it? Probably not, right? I need to actually have different names. And to actually have different names. Or I can make this over here scoped in the like actual core, so module core is struct like that. So that's the core, and this is like the plugin already, and I will name it Ogma. And then over here I will include the core in the end, so I'll override it back. Right, so this over here should be core type plugin. I kind of like don't really want that. Can I include core here and then I can include it again? It's weird. It's a little weird. So this should be core type T, right? That's the difference. And so the value here is actually always going to be type. This is not exactly this type, actually. Add it to my wish list. I'll buy it when it's released. But it was a very original game. Thanks. Yoasty has a Nix flake when it has Zig compile times. Are you saying that Zig actually is compiling very slowly? Because that's what you said before. Link, link, link. You heard it's compiling slowly? Okay. Let's download it. And it'll take a little time to download the dependencies, I guess. So this, yeah, because so this over here, I cannot specify that this is the type. Can I have the type of this to be at least this? Is that possible in OCaml? Is that possible in OCaml? Or can I, or do I need to have something like this? Module. I mean, I can have over here the signature, right? I can do this. Include type plugin. Yeah, I can do that. Include type plugin, and then I will also have the value, which is like make. Because this one also only has a single value. Make. Just T, I think. So I'll just have a make is this. So over here I will say type make. I will say type T, type make. I don't want to refer this to type. I want to say that, like, this is just wrong. I want to say that this is error type. Error type make, actually. Maybe that's how I do it. Yeah. So maybe these are like separate ones. What if I say module error type? But that would be weird a little bit, right? Like, what if I change this to be module error type? And then this over here is going to be module error value, and then then later I will like actually combine those together for like referencing in the other parts of the code, where I say module value is error value, and module type is error type, right? And this way I don't need to like say that this returns core type, it should just return type, but this over here is error type, right? Like this. Yeah. That makes sense? Type of. Okay. So yeah, this is like the only plugin in the core which specifies the errors. Okay. I mean, let's move one by one. For example, a unit. So a unit plugin would actually be extending the compiler, because it will need to compile the unit syntax. It will extend the value, which it introduces the value unit value. It will introduce the unit type, and it will also introduce the way to evaluate the unit expressions. Although I guess we don't have the unit expressions here, we will just have the const expressions. Which also means that maybe one of the core expressions that we should have is the constant expression. Right? So that also is like kind of in the core. So module const. Module const would be an expression plugin. Right? And so what is an expression plugin? But expression plugin should also be like evaluated. So do I call it an interpreter plugin? Because it needs to have both that and interpreter. Interpreter depends on the expression, but an expression plugin does not. Maybe I will say in this that is that in the end, expression is struct, which includes the original expression, but then we extend it. But then we extend it over here, saying that module type plugin is. So what do I need for that? First of all, we need to extend the expression itself, right? So we need to, yeah, first of all, we need to say type T. So this is an expression itself. So we need to introduce a new type of an expression. We need to say what the expression evaluates into, right? Result. What expression evaluates into. And then we need to have the function evaluate, which takes interpreter, state, and the expression, and returns the result. Multiple definitions of the module expression. Names must be unique in a given structure or signature. I hate it. Why do I need to come up with a unique name here? Why can I shadow it in other places, but in this place I cannot shadow it? Huh? What if I specify the plugin types in other places? So first I specify what are the things themselves, and then, so this is the core, and then we'll have module. Hold on. So like this is the core. Let's call it core without plugins. And then we'll have a module core with plugins. This one is going to basically have all of these things, right? Which is a type. So module type struct include core without plugins type, like this. Type value expression compiler interpreter. And over here I'm specifying the types of plugins, right? Because the plugin for the expression will also extend the interpreter, kind of. A little weird. And then like these plugins here of the value are here. I mean, yeah, like it's just like over here I can actually specify the interpreter before the expression, but in the core without plugins I cannot do that. Unless I make them recursive modules, which I don't want to. Are you making your own language? Yes. Hello, hi. Theory 1. How are you doing? I am trying to like refactor my code right now specifically, so I'm like trying to change the code into like restructure it into a set of plugins where each plugin handles a certain feature of a language. But the language itself is like You can read about it on the website a little bit, even though the website is a little bit outdated. But some of the things are still like specified here. Here's the playground, which is can show the current state. I have the online playground, and with language server syntax highlighting and stuff. And here's a guessing number game that you can play, written in the language. But I've been rewriting the language multiple times. In this rewrite, I have mostly focused on the language server, so that the language doesn't have much features right now. Except for, like, the editor support. But there are supposed to be a lot of features. It's supposed to be the programming language, right? So we will probably never get there, actually. Launch module core. I guess core with plugins should just be called core, because that's like the final one. Maybe later I will rename it if I want to like extend it further. So we build the core in like in stages. First we specify like these types, and then we specify the plugin types. Yeah, sure. Okay, so we have the expression plugin. Actually, constant, yeah, should wait, hold on. Constant should yeah, I don't know. Maybe it's not like even worth it. But let me just do it without that. So what should a constant be, right? It should define a new expression. So there is going to be a constant expression. So yeah, I guess constant expression specifically is a expression plugin then, because constant is going to be more than just the expression. So type T is basically a value which is of type value, right? So we just have a value as a constant. Say type expression plus equal T, which is T into value T expression T. Expression plugin. This should be called T, not expression, probably. And so this, so yeah, the result of the expression is going to be value. So this should be this into result. Always, right? Yeah, so we should have type expression type wait, what? How did I do this in the value? Oh, type t dot t. So type t dot t plus equal t, which is t into result tt. Is that it? Type underscore like this. There you go. Okay, and then we need an eval. So basically, I say, how do I evaluate an expression, which is the expression which is a constant one, using the interpreter, which is interpreter. This should return result, which will just return expression value, right? Because that's the simplest expression ever. And we don't even use the interpreter for this. Okay. Oh, by the way, I forgot. I need to actually, since I have registered the plugin, I forgot to register the plugin, right? So whenever I say that this is a plugin, I need to make sure that I need to say like type register plugin module error type, right? And then I need to and then to say this is value register plugin error value, right? This is a first class module. Okay, and this over here should be expression register plugin module const expr, like this. I will then have module const struct where expression is const expression. So expression register plugin is going to be interpreter register evaluate function, where function is equal to plugin eval. No, where function is equal to function. And if it is plugin type value, it's going to be that. Otherwise, it's going to be none. And in this case, it's going to be some function interpreter into plugin evaluate value using the interpreter. Is that right? The field has type C, 0 into CT. Register eval function. AB, A into B expression T. Hello, Tart Kebab. Wait a second, is this correct? Is it let's general? Then A, B, A into B. T. But this is one is 0 into C. T. Interpret T into C option. Can I say colon here? A, B, expression T, A into B, expression T, into interpreter T, into B option. That's the type, right? Wait, what's the type? Wait, what? Oh, what's the type here? Eval function. If I have an expression like that, it gives me, yeah, interpreter into B. Yeah, this is right. I cannot specify the types here, right? Oh my god. This pattern matches values of type P result, but a pattern was expected which measures the type of 0 into AT. The type constructor 0 would escape its scope. Did I specify the types here incorrectly? Should this be without parentheses, potentially? I don't think so though, right? This is a GADT. Oh, wait. No, this is an expression. Hold on, this is not a function here, right? Yeah, this is actually not it. If I do a GADT, the argument here is just only holding the result type. But I should also have the argument type there. So should this be like a comma? Should this be like, can I have two arguments here, underscore, underscore? Is that possible? Can I have underscore, comma, underscore? I can do that. So it's like two arguments. So it's a GADT with two arguments. The data stored inside and the result type of the expression when it's evaluated. So it's like GADT2 or something, which has two things. So this would be like A and B, and this one is like A and B, A, B, into A, B, T. Is this even what I want? So we have an expression that has a value A returns B. Like that. So this should be not T into result. It should be T into T and result, TT. And register plugin. So now if I have value, this field has type PTP result T into interpreter into P result option, which is less general. Then AB. I feel like I need to have like an actual function here, which is polymorphic, because otherwise it is inferred as something else, right? Maybe it should be like function, like type A, type B, value, which is TT, AB. Right, and this thing returns match value with that. Function interpreter evaluate is just T into interpreter, T into result. This field value has type C. CP result. Into interpreter T into P result option, which is less general than AB. So it could not figure out the result. Like why did it figure that out? Hold on. F. Maybe I can do like a let F. Be that. So I want specifically to have a function A, B, into A, B, TT, into interpreter T, into B, option. Right? That's what I want. The definition has type this. Okay, which is less general. Can I say over... maybe it's because I did not specify the result type here, actually. So the result type should be interpreter T into B option. Okay, actually, it's because I did specify the type, so it was too stupid. I can say, I can inline it here, and then... Okay, there we go. That works. GATT is a little bit weird. Okay, so now we have the const expression. So this should be type expression has now two things. So this should be like T into result expression like that. And now we have this, and I have registered the plugin. Okay. And also I want to be able to, yeah. Okay. Okay. How do I test this? Let's make this into a binary executable so that I can actually test this, you know? This is main. So I'm just going to construct an expression. Expression is expression T. Is going to be a const expression of a value which is equal to I mean the only value that I have is error. Error value should have like I should be able to make it. Devin's dev, hello. And then I should be able to just like interpreter evaluate expression. So let result be interpreter evaluate expression. Interpreter where interpreter initialize, right? And then I want to say a value print result, right? So I will say something like print ln send a value print result. Result is const expr result. The value result has type const expr result. When expression was expressed of type of value T, but const expr result is equal to value T. It's because this is value plugin. I guess I should say specifically here with. I should say with result equal to value T, because otherwise. With type result is value T, because otherwise it doesn't know about that. Unbound record this. Yeah, and like this also, yeah, okay. I guess like if I don't say the signature here, it's just like, yeah, I guess. I mean, the signature is going to be checked because I'm registered the plugin. Okay, error value should have, this should have, okay, I guess I'm removing the annotations. So similar to type, should be able to make it. I feel like this should be functions, not normal values. Like that. So make like that. The expression has type unit, but expression was expected of type value T. Oh, right, because make should actually return T, like that, right? Because this should return actually the value. Okay, and then interpreter init. So interpreter init. Yeah, this is the part that I need to like still figure out how to have a plugin of this structure instead. Yeah, so we'll have a function in it. The T is just I don't know. I guess we have the units here for now. Right? I don't like the fact that it removes the empty lines for me, the OCaml format here. But whatever. Okay, so can I just run it? Like Dune exec Dune exec cast core. Dune exec source cast core exe. How do I run it? Like this. There we go. There we go. It actually works, right? There we go. We have an error. Nice. Error means that it works, by the way. Yeah. Error means it works. Trust. Because that's what I'm trying. Because that's what I did here. I registered the error plugin. Error always means something is correct. Indeed. Yeah, there you go. I mean, I can try. Let's just. Yeah. I mean, yeah. Yeah. Sure. Okay. Yes. So like this constant could live in its own like library. I mean, errors could live in their own library too. Then also like for the constant to work, obviously, right? We will need to. I mean, yeah, the only value that I have so far is the units, right? So constant is like I think that's all about the constants actually. But then we will also have the module units, right? So unit is a module which will define several modules. First of all, we'll have the unit type. The unit type, which must be type register plugin module unit type, right? So this must be print t and everything. So we say type t plus equal t of t, and type t is unit, I guess, because we don't have any associated data here. Then we say print fmt formatter into, I mean, let's see, fmt value is printf t. Okay, yeah, there you go. I feel like in these cases I will not be typing because it's the signature. It's in the signature already. So we have unit type, right? So unit will have a module type is unit type. Then we'll have a module value is unit value, right? Module unit value. This be value register plugin module unit value. So unit value should have a type t as unit, type value t plus equal t of t, and then print fmt is fprintf fmt, like that. And value also needs to know the type, right? So we will say type of this is equal to type is equal to unit type t Unit type. I mean, unit type just unit type T. I mean, that's what I want. So the unit defines the unit type and unit value, and we'll also need to specify the way to compile things, right? So far, we only have the interpreter, not the compiler. So compiler has been empty, right? But what is the compiler? Compiler is a thing that should, so like this over here will depend on actually on the AST, I guess. On the AST. And compiler needs some state. We'll need to initialize the compiler. And then we need to basically have the core syntax, right? Right, so we'll have a thing which is register core syntax. And this should be having a name. And then all of the things that I have in the current core syntax stuff, right? So here's what we want. We say core syntax has a name and a handler, which is this. Yeah. Okay. Let's do it simpler for now. Register core syntax. Core syntax. Unit. Where type core syntax is name. Why did this open? Name string. Implementation is for all A. Because this should because expressions have different types, right? And depending on what kind of expression I'm trying to compile right now, right? Depending on what type of expression I'm going to compile right now. It's going to compile it. So this should basically take AST. This should take AST. Yo, sorry, thanks for the read. Yo. How's your stream? What were you doing? Game jam entries? You game jamming again? I have not been game jamming for a long time. I'm trying to make my own programming language, and so I'm the plan is to make the programming language usable enough so that I can start participating in game jams with it. But I don't know how soon is it going to happen. You've done a few game jams recently. You like playing games? Have you played my game? Here's my game. Wishlisted now, right now, or else. Okay. So yeah, like I just said that I'm making a programming language, and I'm trying to come up with a plugin system for it. Why? Because that's one way to not do any actual work. Function. For syntax. Unit. Okay, so this implementation, so the core syntax is a thing that's converting the AST into the expression. Into the expression. But which kind of expression? Well, that depends on the core syntax, but also yeah, this should have like the expression kind, actually. I should have expression kind as an argument. I should have expression kind as an argument. And AST, the state of the compiler. Did Drop Beer Studio Mini buy gem last week? I never heard of it. Sounds like a cool name though. I know a song about that starts with the words "drop" and "beers." Right, Brainoid? The song about the drop beers and the fact that they are real. Do you know what a drop beer is? It's a large, aggressive marsupial with orange fur and sharp claws. So it's a real enemy. An animal, not enemy. Or is it enemy? No, it's not enemy. So expressions should have kinds. Expressions should have kinds. Type kind dot dot. Well, I mean, technically, yeah, we should have like. I mean, I could have the kinds specified here, kind of, where I'm going to have pattern. Pattern, expression, type expression, assignee expression, place expression. These are all the things that I need to be compiled into. But okay, it's not actually like expression, right? It should be more like compilable. So like compiler should have compilable things actually, like right, compilable. Here you go. There we go. Wait, is this your voice though? This is not your voice, Brainoid. Is it? No, it's not. It is your voice? Did you change your voice? That doesn't sound like your voice. Compilable. So compilable. This one was also the GADT. A compilable. It was something like this, you know. But for now we only have expressions. So let's say that expression is expression t compilable. Like that. Have expression t. Yeah, and an expression. But expressions can be evaluated to different things. Okay. Hold on a second. How do I do this? I want to compile an expression. As a result, I should have an expression. Expressions is though a GADT. The result of an expression is going to be value t. But what's the data? And the data should be like anything. So is that like another argument to a compilable? But that's not how it's supposed to be, right? No, it's not. Is this like that? Oh, it is. Yes. Wait, what? Does this even work? So implementation should be the thing that so like if I know what to compile, then I need to get that thing, right? There it is. Okay. So basically a unit should also say that we want to have compiler register core syntax where name is unit and implementation is function. Kind AST compiler like that. Be kind, guys. Be kind. Robert Pattinson said so. If you're going to act unkind, Robert Pattinson is going to do something. I'm always kind. Same. Unkind. Yes. Right, so this over here implement, so this should just return an expression which is a unit. So yeah, we should return a constant expression. We should return a constant expression with value being equal to unit value. Unit value. This, right? But this field has type const expression t, const expression result, expression t, compiler compilable, AST, which is less general than a compilable, unit A. Because this always returns that, because I should specify type A and kind is compiler compilable of A, and this should return A. Okay, but the constructor has type const expression result, which is not type A. Yes, because we need to actually match on the kind here with, and if the kind is expression, then I need to do that. So now the expression has type const expression t result, but we expected this one 0. So this is the incorrect typing actually, right? On the core syntax. What should be the type here? Because this should not be like, it should just expression. It should be just some expression. Expression that evaluates to a value. Expression that evaluates to a value. So maybe this should not even be the argument of the expression, right? But can I do that? If I remove this And I say that expression t is just having a single one, which is the result type of the expression. Then in order to evaluate, if I evaluate function has the expression t, and this should just return a. Maybe that is actually correct. Hold on, this may be simplifying the things here. This maybe is the correct way to do it. So yeah, we only store the result here. So we just have type A, just have ATT, return A. Looks like it works, yes. There you go. It actually works. Right. Over here, obviously, I don't use the state of the compiler to compile the unit expression because it doesn't matter, right? I just need to check that the AST is actually the AST, but I mean, we can also just ignore it. Okay, I feel like this is going to work. I feel like this is going to work. And then when I actually compile the AST over here, like compiler will have the function compile, which we just take from over here, cast compiler, right? And it checks that if it's a complex one, if it's the core syntax, then we just try to find it using the registered dynamically these things. Yes. Okay, that makes sense. All right, I think I'm onto something. I'm going to keep... I think the overall idea here of the plugin system is there. I just need to basically rewrite my code now using that. So I'll probably do that off stream. And I'm not sure when I'm going to stream next time. I'm going to probably do a bunch of stuff off stream because I will also need to do other things. So, yeah, that's going to be it for me today. But I will commit this. Minicast. Oh, no, not minicast, this one. Plugin system proof of concept. You forgot about Ghosty? Okay, fine. Oh, it still is downloading the dependencies for it. Oh wait, no, it's asking me, do you want to allow configuration settings extra substitutors to be set to Ghosty caches? Oh, they have their own like cache of the nicks even. I'm not sure if this is doing it temporarily or like globally, so I'm probably not going to do that. Okay, look at this guy's beard. It's so long and beautiful. I'm going to send you here. See you next time. Thank you for watching. Bye.
I don't know. I don't really like this interaction here, but we'll see how this goes. It might not work at all.